Good morning.
Morning.
Seems to be working a little better today. What's up? Good morning. Good morning.
I have a question.
Okay.
So we have Zoom meetings on the days that we have tests also?
No, ma'am. We're just going to meet and test.
Okay, so no Zoom meeting tomorrow.
Now, and what we'll do, we'll talk about that. Hey, thank you, Miss McKinney. Help me remember that because I'm an old man. I forget about it. But we'll try to. What I'll do is we'll meet here at 9 for the test.
Okay.
That seems to work out pretty good. That gives y'all a little more sleep, right? I think that'll work. I'm just gonna. I really need a little bit of that lecture after the test, but I just think at this pace we're just gonna have to. Y'all gonna have to just assume y'all getting some of this. I'm not gonna be able to do quite as much talking as I want to, I guess. Okay, we're getting everybody in. Is everybody in the waiting room? Okay, here we come. Let's give everybody a minute to get here. Man, it's working today. Man, I was so upset yesterday. I apologize, guys. I was really perturbed beyond belief because I had thought I had planned better, and I can't believe they updated this thing. Absolutely crazy. All right. Y'all help me look for anybody that comes into the waiting room because I don't want anybody to be out there and can't get in. Give everybody another minute here. It's not quite even 8 o'clock. We already got 23 people in here. Very impressive, guys. We lost a few people yesterday that we had that whole summer schedule was a big mess. I mean, we just, of course, things are changing every minute. So we just did the best we could. But our science division does not believe in online labs, especially in majors class. And there's 22 instructors, and we've unanimously agreed that we were not going to teach some of these like A&P and chemistry and physics online. So it's kind of a long story of about us standing up for what we believe, and the school really backed us on that. And so by doing these labs at 9, that was the compromise, which I think, life is compromise. Those of y'all that ain't been married yet, y'all learn that very soon. The life is all about compromising and reaching a consensus and trying to do what's best for the most people. Anyway, I'll try not to preach today.
I have a question.
Yes, ma'am. Shoot. This is a good time. And I want to try to get in here about 10 minutes early. That way, if y'all have just general questions, we can do that too. Yes, ma'am. Go ahead.
I have a question about lab. So I have micro lab with at the DeSoto campus, and yesterday he went off a list of all the people who had a COVID form turned in.
Yes.
Could you do that ahead of time at the end of the lecture today to see who has it? Because he made some of us leave if we didn't have the form turned in.
Okay. What he was supposed to do was to take you down to a computer lab and have you do it then. And then they let us see it on the computer. But I will tell you guys, look, these are strange times. And look, Dr. Adris is a nice gentleman, but I'm trying to I seem to have trouble getting him to follow along with simple things like that. So I apologize. I shouldn't say that, but I'm just being really honest. He's a good man, okay? And he does I hear he does a really good lab, okay? But he was supposed, and maybe I'll take the blame for that. I didn't communicate that well enough. But today, what I'll do is if you went online and did that, you're good. I have a PowerPoint I can pull up and this week. I'll do that. I also got to make sure that I don't break anybody's what's the word I'm looking for? It's early in the morning for me. I'm not. There's also legal ramifications. I can't show you everybody else's grades and ACT scores. That would be unethical. But I will tell you this: one of the other classes in DeSoto had a COVID positive person who came to the building to do lab, and they had that person leave, and they're going to work with them online. Because we got a lot of this we can do online, so he has to stay online. He'll be county president, but he can't come to the building until he tests negative. You know, till he's passed the 14 days. I was not involved in that decision. My boss, I think, made a pretty good decision. I might have told that person to wait till this fall. I mean, this is most of it. I mean, this is life and death is not important when it comes to a semester, right? Another month or two taking something, but yes, that's a great one. Whoever said that, guys, thank you. Whoever said that, I'm trying to still learn nobody's names, and I'm terrible with names. Y'all got to bear with me, okay? But that is a great point. I will when we get to that. I know several of y'all got to get in the car and get up here. I know that. But I'll try to do that and pull that up. But it's okay. Like, tell you what, just come on. If you're registering a class, if you didn't get it done, I've got a computer lab right across the hall from our lab, and we'll just go in there and let y'all do it real quick. I had to do it too. When I came back up here in April, I had to come to the building. I just had to get some stuff out of my office. We had to fill it out too, so everybody has to fill that out. But good point. He probably was very flustered about that positive. That scared a couple of teachers. You know, that somebody walked in and said, "Hey, I'm positive," and at least they, by the way, they were truthful. That was the main thing. And I just want y'all to know this too. This is a great point. I want to say this real quick, and y'all just hang on. I'm letting everybody in. But if you do have a fever, do not come to lab. If you have a fever, if you feel sick, it is not worth endangering everybody else. And I'm just here to tell you that if you do get sick and miss a week of lab, I suspect we're going to give you an incomplete. We're not going to F somebody out because they were not coming to the building because they may have coronavirus. That's just not going to happen. Okay. And I'm a big advocate for y'all. If I have to go over there and scream and holler, I mean, we go get some money back or whatever. You know, we're not going to do that. But we have most of the A&P 1 and 2 already, half of it online already done. Because when we flipped in March, we did the second half of both of these online. And two of my superstar teachers, including Miss Nickens, was what developed it. And also, when I was working last night, I found some more stuff that I can put online for y'all. So you'll see in lab that I'm gonna make online and other work kind of 4th year grade. I'm actually making the grades a little bit easier this summer. Life has always changed, but for lab, the midterm's gonna be a 25%, final 25%. We're gonna have weekly quizzes or daily quizzes, not starting today, obviously, but starting Wednesday. Then they'll count a 4th, and then I'm gonna do online, what I'm calling online homework, and some sheets out of the lab book that y'all turn in, which is spot grades, should be hundreds. They'll count a 4th, okay? So I actually have planned much better. I have a lot of them going on. I think I've done a pretty good job, but then I came over here yesterday and the thing ain't working. It's very frustrating. And I did fly through chapter 1, which is really not that big of a chapter. Good morning to everybody. Some great questions. Let me say that again. And by the way, if somebody comes in, I've got 28, that's 27 students. That's amazing. But if somebody gets in that waiting room, I just did that because there are people breaking in, doing profanity, putting pornography on these Zoom broadcasts, and we want to try to minimize that. If y'all read some of that, people breaking into these. So I love that password. That should help us out. In the holding room, maybe I should have not done that. But anyway, for lab today, make sure you've done those safety things online. And I do get a print off. And if your name says you hadn't turned it in, I'll let you go into a computer lab and do it. Okay. But we've already talked about this. If somebody like this young man at DeSoto, I think a woman who I don't know what it was, man or woman, but the person that tested positive, they are giving him online work until he can come back, which I thought was extraordinary to do.
Where is the lab?
Ma'am?
What room is the lab in?
I think we're 207. Madison Science, okay. 207. Now, for those who've never been to Senatobia, come to the college. The college is on Highway 51. And you'll see a Burger King. Turn onto campus at the Burger King, not at the junction by Walmart, but on the Northwest property. You'll see it's called Coliseum Drive, I believe. And come down about 4 buildings, and there's a big 3-story building on your left, Walmart will be to your right, and a big Northwest parking lot between my building and Walmart. So you can get in there. There's a parking lot. We can all have our own row, okay? And I've already opened that door on the side, and we're on the 2nd floor. My office is down the 1st floor, okay? So if you want to, and I actually look, the school that my boss came over and had a great visit with my boss yesterday. She's excited about y'all being on campus. I suspect she'll drop by. She brought me about 400 masks. So I've got masks to get us through 2 or 3 weeks. Northwest is providing masks. Okay, and they're pretty cool looking masks. They got me one I got to go pick up. It's got Northwest on it. I thought it was pretty cool. But I've got to go pick it up, and I haven't got over there to get it yet. And I have found gloves, but if somebody, I know some of y'all may have access to gloves. I'm not saying you stole them. I'm just saying you may have a friend or you may know if you can bring some gloves that'll help us. And a lot of times I do bonuses for things like that. Like I can order cats, but I can't order, and Sean understands this, but I can't order paper towels. That looks weird. If I order paper towels, then people get on my case. So for about 30 years, I've been telling everybody bring a roll of paper towels for 5 points on the first week of the quiz. Okay. And so I do bonuses on things that, like that mutually help us, right? Like paper towels. And I got a feeling that I'm going to get bonuses this summer for gloves, because I'm going to wear gloves in lab so that everything we touch in there, I mean, we just want to be safe. Just don't touch your face. And then when we leave, we'll throw them away. Okay. But I will say that we've all talked, and like I said, I think the labs are going to be very fun with just 8 or 9 people in them. I'm just really thrilled. I've never had a class that small, so it should be quite entertaining, I hope. All right. Good stuff, guys. Anybody else a question this morning before we get started?
I have a question.
Okay, go ahead, fire up. Who is it? Okay, Miss Mallory, go first. You can hold the space bar down. You have a question, Miss?
Can you hear me?
Yes, ma'am.
Okay, I noticed that I'm not in your lab, so should I be in your lab?
No, it's okay. Look, here's the deal. I want, in a perfect world, I wanted y'all to call me, and I was going to put everybody in the class. And in the process, my boss just opened them all up. So I spent most of last week cleaning up this lecture to make sure everybody got in the lab in the day that needed it. I mean, I've been begging people to move. If you're in the online, you don't need to be in these labs. You should be in an 8-week lab. But if you have Mr. Carrero, as long as you're taking the lab at Senatobia, in the morning, like at 11 or 1, Mr. Carrero is one of my, I've had people come up to me, tell me how lucky we are to get him. He is a young man, about 28 years old, just got married. I guess of his mentor, I love him to death. He's doing a great job. He's right beside me in labs. I'm going to be right next door. It's okay to have him. Matter of fact, you'll get 2 observations about the same stuff. Okay. So you don't have to have my lab as long as you're taking it in the 4 weeks, you're fine. And if you have a question, come over and talk to me about lecture. And you can ask him about stuff. He can explain stuff maybe that I don't get to you very well. So you do not have to have me. As a matter of fact, my intent was I didn't know how many would take it. So my intent of getting him involved was to give him the labs this summer, and I was going to do the lecture and just kind of split it up a little bit. But so many of y'all decided to take this, we were able to and they allowed us to do 9, that we have 4 labs. So he's very happy. He and his wife are going to be able to remodel their house this summer, and I'm going to be able to take a trip to Florida in July because of y'all, and I thank y'all. Okay.
Okay.
We're very excited to get to teach the 4 labs. He's actually doing one right now at 8 o'clock for the people taking the online class. So he's already done one last night. He has 4 night labs. I mean, so if something happens and you get sick or something and you miss one of these, like you got to go to the doctor appointment, I mean, you can come to the 1:30 anytime for me and him if there's a seat. We just can't go over 10 in the room. But right now, I think we got about 8 in every lab. So there's actually an extra seat in case somebody car breaks down driving over here. You just come on to 1:30.
Okay.
For him. We're doing the same thing. I made the schedule out. I gave it to him last night. He was thrilled.
Okay.
But no, you're good.
So,
That's a great question. Anybody else?
So is it okay if you go to a lab at the DeSoto Center?
I would not do that. And it may be, and I haven't had time to check everybody. Here's why. That is an 8-week lab, and we will be through on June 25th. And I have seats down here. If you can drive to Senatobia, well, look, you're already in this class. If you plan on taking our 6 tests, you're only going to have to make 2 trips down here. You wouldn't come down here anyway for lab. 3 of the tests are on Tuesday, Wednesday, Thursday. So we're going to have lab anyway that day. But if you can drive down here, I just think it makes more sense to take a 4-week lab for the 4-week lecture. Okay. And somebody made a slip through. Who was that?
Awesome.
Okay, Miss Carr. Now, but I'm okay if you want to do that for transportation reasons. Okay. You know what I'm saying? If you want to do that, that's fine. And that's why I let that go. And I actually asked my boss to I was even willing to let everybody take, if you have like a high ACT, you can take AMP1 and 2 at the same time. But my boss actually did not want that to happen because we really do believe that AMP1 sets up AMP2. Unless you're just a genius, and I'm not a genius, you shouldn't take them together. Okay. But if you've had them before and you're repeating it, I'll let you do that. You can take them all at the same time. Okay. Anybody else?
I have a question.
Okay.
Do we have to wear like loose or not like any specific type of clothes to lab, like not loose fitting or not tight fitting?
Okay, that gets me there. We have a lot of laughs about that. I mean, in general, some of my people get really upset, and then I got one of my older my older teacher wouldn't mind if everybody wore a bikini. He, just wear reasonable clothes. You know what I'm saying? Wear blue jeans, wear shorts. Don't wear lingerie or whatever in the lab. I actually had to make somebody go change their clothes one time. Girl wore what I think one should sleep in to class. And I said, I know your dad, girl. Go put some clothes on. But no, I may put your hair up. You might want to put your hair up and not have it falling down on stuff because you could, I think that's the point. And don't wear flip flops and stuff. I think shoes probably because we do have knives and stuff in AMP2 you can drop and cut a toe off or something like that. I don't think there's a lot of danger in biology lab as far as clothing. I love that. Thank you for asking that. And I've never sent anybody home on a 40, 50-minute drive over clothes. I mean, come on, be reasonable. You can just say something like, hey, I would not wear my best clothes to lab because we will be using stains on Wednesday and you'll ruin your pretty shirt. Just like you got a t-shirt's fine, and some and shorts and just don't you don't have to have long pants. You can wear shorts to lab. Yeah, in summer. Yeah, it's no problem. Good question. And I'm going to go over all that today in lab. And like I said, I'm not going to call anybody out today in lab. You know what I'm saying? It'd be like later on if you came in here barefoot on Thursday, I might say it. Get some shoes on. Good question. All right, we good. Everybody ready? Everybody ready for 2? Go for chapter 2. Okay, let me sit down. Y'all forgive me here. Let me get this thing going here. Let me pull this back just a little bit. Okay, here we go. I've got to share the screen. I hadn't done that yet. Hang on. Okay. Well, guys, look, I hope I didn't scare anybody too bad yesterday. And like I said, I do apologize. I was very frustrated about the darn computer thing. That was really embarrassing. And I rarely embarrass myself. Well, I embarrass myself a lot, but no, second thought, but that really irritated me because I was here early this morning, yesterday, and technology failed me. So the lesson is don't wait the last minute to do this online homework stuff. Several of y'all, I don't think it's maybe 1 or 2 of y'all couldn't find that code, scroll down and menus, right? It's in there and it works. I know somebody had a little bit of trouble. I would say, watch out for those pop-up blockers, make sure you're using Google Chrome or Firefox. Don't try to do it with Safari. You will get into these tests and you won't see the answers. That is very scary. Like it'll say, pick an answer and the pictures don't appear. And so watch that. And today I will probably in lab today, probably help anybody that had trouble getting in to mastering. The homework, we can take a little bit of time at the end of lab and go into the lab and do that too. Okay, so we can do that. All right, here we go. We're going to go for chapter 2. If I can make sure I got the right one here. Here we go. Everybody see that okay? Everybody got chapter 2 up? Does that come up, y'all? Yay, nay? Can y'all see it? Yeah, hang on. Oh, I didn't hit the share button. Hang on. Now y'all see it? Okay, thank y'all. Yeah, I was telling some other teachers how good this was I moved my camera over here I have double screens. And watch me not be able to do it today. But yeah, I thought this was really cool. I could see y'all. As a teacher, it's very frustrating when you can't see people. And so like I've got y'all all over here on the screen on my right with me over here. So I moved my camera. So when I look at y'all, I'm looking at y'all's face and y'all should be seeing the PowerPoint, right? And please look, give me a thumbs up and give me thumbs down on something hard. And y'all know down at the bottom there's some emojis you can hit to tell me what's going on, like raise your hand or thumbs up stuff. And guys, look, I do appreciate y'all turning the cameras on this morning. I am not a morning person by any stretch of the imagination, although normally I would be at church camp this week with Sean. And so I'm a little bit depressed about not being able to discuss all the things going on with all my friends at camp. But and I appreciate your post yesterday, Sean, with the empty camp gate on Sunday. That was pretty wild. That was pretty moving. But this is one of my favorite chapters. I think it should be quite entertaining. Did everybody see that I posted the chapter 1 last night on YouTube on Canvas? So I know several people missed it. One young lady had trouble getting in, getting logged in. So I'm gonna do that again today. I'm recording it, and please don't slice any of my comments and make me say things I didn't say and do some kind of crazy video on some social media thing. That's just kind of mean, but still, I'm gonna put it out there because I do think y'all may want to go back and read. What did he say? Because I talked really fast, and you can go back and hear one segment of what I said. But please use that if you want to, and if you miss or something, it's there. Okay.
What did you put it under? I didn't see it.
It's under, you roll down, go to modules on Canvas and scroll down, and it's got a big link. I think it's got this picture of all y'all on there. It picked this picture for the thing to click on. I will tell you, when I first did it, it came up something else. It had some dude preaching, so I had to be very careful. They linked it wrong the first time. It was somebody really rolling, man. So, but I think I got it straight. Okay. All right. And oh, by the way, somebody raised their hand about an hour or maybe less, and let's go to the bathroom, take a bathroom break. I was 22 minutes late yesterday, and I think I went an hour and 40 minutes without breathing. So, you know, I didn't take a breath. I was trying to get through it, trying to stay on task. But let's take a break. And if you need to go to the bathroom, go to the bathroom. Y'all at home, I mean, don't go get coffee if you need it. You know, you don't have to. I mean, I'm not going to be mad if you step away for a second to take care of a kid or something too. You know, understand that. Okay, but that's okay. But I will take a break in about an hour, and we'll try to give y'all a chance just to stop, and maybe you'll feel better about asking a question if I'm not talking directly. But seriously, all you got to do is just raise your hand and hit. You can hit if you own a laptop or personal computer, hit the space bar, and that unmutes you, so you can hold that down like a mic, you know, like a old walkie-talkie, if you want to say something to me. Okay. Okay, so let's go to chapter 2. And chemistry is, boy, this is a chapter that scares a lot of people, especially if you didn't have a good high school background. And I know, I mean, look, we're a community college. I know that some of y'all went to some very poor schools, and we have some very sad schools in our district, but we also have some excellent schools in our district, right? So just be aware that I know we all come from different points of life here. And so some of us have had a really good chemistry experience, and some of us have a scary chemistry experience. But I'm going to do my best to kind of walk through this, I think, in a very simplistic manner, because to really understand the human body, and I think to be a very effective nurse, you're going to have to know a little bit of chemistry. And if you end up doing a BSN and a master's degree, which I hope y'all all do in nursing, you must take chemistry 1. It's required, and that's a pretty basically, that's a pre-med class that everybody trying to be a doctor takes their first year, and it is quite evil in certain universities. It can be quite difficult, okay? So maybe I'll say something that helps you get a feel for it, okay? All right, so, and this is kind of where we get at. Let's just kind of go for it. Okay, so everything in the universe is made out of matter, okay? And basically, there are 3 states that all matter can be in. It's either solid, liquid, or gas. Now, I'm a big sci-fi person. I watch way too many movies. Matter of fact, the only book I really have read here recently is the A&P book, the Majors Biology book, the well-written A&P Lab book that you will be buying today. And that's a little publicly, you know, that's me punching my own book, and the Bible. Pretty much every other book, I'm waiting for the movie. I like movies. I watch Netflix, and I use a lot of movie references in here. Okay, so a lot of them are old movie references, so y'all forgive me. But unless some alien comes in like Independence Day and blows up the White House, and they can make a billion-pound ship hover over the White House, there are certain laws of physics and chemistry that we believe everything must maintain. And so I would be very surprised if somebody could walk on water and that kind of thing. You know what I mean? So we're going to go with the known properties of nature, and here's where it's at. Everything in the universe is made out of 92 different elements that are naturally occurring in the universe. We have never found a meteorite, and we're exploring other planets, and there are no other elements until, I'm knocking on wood, until we discover something else. Now, there are elements over 92 that are man-made or woman-made in the laboratory by adding electrons, protons, and neutrons. So when you look at a periodic table, everything over 92 does not naturally occur in nature. It was man-made. And I must say that I thank God that you cannot go out here and dig up plutonium, or some terrorists would have done blowed up this country, quite possibly. Okay, so plutonium has to be made. Uranium can be found in nature. It's like 92, and it is used to make nuclear weapons, the lower level ones. But some of the very big ones that can blow up a whole city or all of North Mississippi involve some of the higher elements that are made in the laboratory. And you see that in the news where these people are, like Iran is trying to get weapon grade, uranium, plutonium or something like that. So anyway, so chemistry, though, is really explaining how everything is made. And since we are made out of those same elements, then it's very important in A&P to have a little bit of chemistry. Now, the basic structure is very cool. The basic structure is this. All elements and let's look at the periodic. I'm going to jump around a little bit. Let me find. Here's the periodic table. This is designed to show you the 92 naturally occurring elements. There's a big chunk out of the middle called the transition elements that have been thrown down somewhere else, I believe. But you can see it here. Each row represents a shell of electrons. And as you go from 1 to 2 to 3, you're adding another proton. Okay? So basically, there is a brilliant design in the periodic table. And you can see, so everything in the universe is made out of these 92 elements in some combination. Think of it like there are 92 different Tinker Toys that make up everything in the world. Or Legos. I know Tinker Toys is real old school, but everybody likes the Lego movies. So 92 different Legos make up everything. And what we're going to see this morning is that these four that are orange in this picture, carbon, nitrogen, oxygen, hydrogen, make up 96% of humans, of living things on Earth. So we are basically a carbon-based molecule. And I always make a joke, if you ever get abducted by an alien, be sure and tell them that you're carbon-based and ask them what they're made out of so that maybe they will not kill you and put you in a jar. Maybe they'll put you in a zoo on Alpha Centaurian. I mean, I'd much rather be in a zoo than being in a preserved jar like I have on the 3rd floor of zoology of the rats and the cats and everything in a jar, right? So maybe you get put in a zoo, okay? But anyway, but to me, it's fascinating. And look at that. If you throw in those other green ones, that makes up less than 4% of your body. So 99% of you are the orange and green, and then those blue ones are trace elements. Notice that we don't have hardly anything down below 30. And so we're not going to have to get into that transition elements that some of y'all did in chemistry that gets cray-cray. We're not going to draw no big molecules. I may make you draw hydrogen or something, but we're not going to draw sugar. We're not going to worry about all the three-dimensional structures that you get into if you take Gen Chem 2 and Organic 1 and 2 and Biochem, which, by the way, was the only C I ever made in college was Biochem 2. Okay, that was the chemistry of life, the biology. Okay, so I have had a lot of courses in this stuff, but is this not cool? And so each of these elements, now check this out, each of these different atoms are elements. And so that's the term that throws people off. An atom is just the least amount of an element that you can have, like one atom of carbon, one atom of hydrogen, okay? So the individual atoms, so if you had a pound of gold, which I wish I had today, it would be made out of, avocado numbers worth of atoms of gold. And if you take an electron away from it or add a proton, then you create other elements. We can make gold in the laboratory. It just takes like $10,000 an ounce to make it, and you can buy it for like $1,000 today on the stock market. So we can make gold in the laboratory. We can make the different elements, but it's much easier to just dig them up and then find them already made, right? Okay, now I'm going to go back. So think about this. So any of these 92 elements are made out of this structure right here. Right here. So
I think Robinson.
Yeah, go ahead.
Yeah, I can't see it.
Ma'am?
I can't see the screen. It's like frozen on the first slide.
For real? Okay, that's crazy. Let me see what's going on here. So it's not moving around? Let me pull y'all over here a little bit. Hold on. Y'all not seeing that move? Okay, hang on. I don't know why it's doing that. Let me figure this out. Is that what y'all seeing? Are y'all seeing? Looks like I've got two versions of this running. Let me try something here. Okay, I think I was on the wrong screen. Hang on. Okay, this is weird. Okay, let me try that again. Hang on, we'll get this technology figured out. Hang on. Don't know why it did that. Sorry. Okay, can y'all see that now? Y'all seeing it now? Not? Okay, okay. Come on.
We're seeing the advisor info center screen.
Okay, thank you, thank you, thank you. Hang on, I don't know. Technology. It worked yesterday. Let me try this again. Let me get back to the Zoom. I was able to manipulate it for some reason. Hang on, here's my Zoom button. think I messed up when I tried to show y'all to myself. Do this. Hang on. There it is up there. Okay, now I couldn't find my screen here. How's that? Is that better? Y'all just gotta bear with me. This thing's got a whole, it hit up there. It keeps moving around. It's at the top of the screen. But I did think we got a pretty good setup if I could get this to work right. I do like seeing y'all. Y'all gotta bear with me. Okay, let me tell if it changes. Like I'm having trouble changing the screen. Can y'all see that? Okay, hang on. Okay, here we go. I got it now. I have to set up the slide change on the screen. Can y'all see it now? Sorry about that. I just got to work through this. Y'all bear with me. All right. So here's the deal. So every element then is every atom is going to have a nucleus that contains the protons and neutrons, and then it has these orbitals or shells that the electrons circle it. Now, this works exactly like the solar system, with the sun being the nucleus and the planets circling the sun, like the Earth and Mercury and all of our 8 or 9 planets circle our sun. Now, one of the things that blows my mind here right off the bat here is that the micro world mimics the macro world. In other words, that Earth behind me is circling the sun. It's an electron circling the nucleus that is the sun. And everything in nature is made out of different combinations of these atoms that are built just like the universe. So you look at the stars at night, think about all those stars and the millions of planets that are circling them probably, right? And we have discovered other planets circling other stars. We know that is really happening. But I'm telling you that all these planets and every thinking pin, everything in the universe is made out of different atoms that all look like this. And the only difference between hydrogen and helium is one more proton and one more electron added to a basic shell of one proton and one nucleus circling it. Okay? Are you with me? This is crazy. So watch this. So in other words, hydrogen, atomic number 1, that one number at the top is its atomic number. That means it has one proton. And it also means it had one electron when God created the universe at the Big Bang. Now, what has happened since the Big Bang? Well, atoms that are not happy, and I translate that stable, have stolen or given up their electrons in order to be happy. Okay? So in other words, hydrogen is not happy. And I'm going to get into happy in just a little bit. And it's a very unhappy atom, very unstable atom. Okay? If you've ever heard of a hydrogen tank blowing up, it would blow up the whole classroom. Okay? Very dangerous gas. Helium is a very safe gas because it is atomic number 2, and it has 2 protons in its nucleus and 2 electrons in its first shell. So the atomic number tells you the number of protons an atom has and the number of electrons it had at the creation of the universe. Okay? Now, we're going to get into sharing and stealing in a little while, but if you can just trust me on this, I can't tell you how difficult I've had people struggle with chemistry over 30 years of teaching here, and I taught about 5 years at Ole Miss and undergraduate. So I've done it, and that, once again, that don't make it me better than anybody else. I'm just telling you, I have experienced many people really almost change their major over chemistry because it's so scary to them. But when if you just let it sink in and let it sink, and we don't have a lot of time in summer to let it seep in, and I hate that. I do like the whole semester where you have a little more time to think, to reflect. But just trust me, guys, this is not that hard once you see this point. So one more time. Each atom on this periodic table has a different combination of protons and neutrons, and it makes it act differently in the physical world. In other words, now the one that's really important is carbon, atomic number 6. It has 6 protons, 6 neutrons, and 6 electrons. Okay? And we're going to talk about why it's so important. Okay? And just a little while. Super big, important. There will be a short answer question about carbon on your test tomorrow. Okay? You know, why is it so important? So make sure you get that question answered before we stop this morning. Okay? And we'll go over it a couple times. I'm real big about short answer questions that I go over, and that's when you need to write that down. I love I'm seeing about 20 people right now writing down that's coming. And those people are going to nail that question tomorrow on the test, right? Because I'm going to answer that in just a little while. Okay? Now, is everybody okay with just the basic setup here of what's going on, right? You with me on this? Okay. Now, one thing I'm worried about this morning, and I don't know how I'm going to address this. If I lecture from home, I have a PowerPoint that I have an iPad that I have an app I can draw on the iPad. I like to draw, and when I try to draw this mouse, I look completely stupider than I looked yesterday morning at 8 o'clock. Okay, it's bad. So I'm going to try not to draw atoms. Normally I would draw a few atoms, and I don't know if I could even try it here. But I will just to go with the pictures here for sake of time. Okay, but let's look at this one. So they draw. This is carbon. Okay, here's the big boy. 6 protons and 6 neutrons in the nucleus, and then 6 electrons in 2 shells. Now notice that protons have a weight. Now look, y'all know we fought about weight in America on Earth for several centuries now, right? You know, we use the most scientists and the guys that, and I love Saturday. It's been a bad week for America, but I cried Saturday when that spaceship went up, because I was born. I was about 5 years old when they walked on the moon, and my mom and dad took me outside and said, "Look up at the moon and look, there's somebody walking on it." And I got the binoculars and I still couldn't see them, but I tried. So I'm a big fan of space exploration. I think it's in our nature to explore and we're exploring the human body in this class. And but I think exploring and figuring out why things are is part of our DNA. But think about this, okay? So protons have a weight of what we call 1 atomic unit. Y'all know that England, we're from England, or at least our government was based on England's government. And y'all know what an inch is, right? That's how big a king's toe was or something, right? And I think somebody says that we got a pound from they cut a foot off and it weighed a pound. And a foot is 12 inches. Thank God the first king they used his foot was 12 inches. If it had a little bitty foot, then a foot would be much shorter than it is today. So our measurements were based on stupid stuff, on weight of people's foot and size of a foot and stuff like that. Well, when we came along with the metrics are based on the physical properties of water. Okay, and it's really cool. 1 gram of water will take up a volume of 1 milliliter, and it will fill a cube 1 millimeter by 1 millimeter size. Okay, and so the metric system is based on the physical properties of the most important compound on Earth, water. Okay, so that makes a lot more sense to me, metrics. Well, when they started trying to weigh these atoms, they weigh way less than a gram, so they just come up with a new unit. Okay, so protons and neutrons weigh the same, so they said they weigh 1 atomic unit. Okay, and electrons weigh like 1/1400th of an atomic unit. So electrons are very, very light. They're always moving like a star, a planet around a star, and they have never been seen. But we know they're there, just like you've never seen a bullet coming out of a gun, but you've seen the hole that blew in a tree, right? We know it's there because of the physics that we can prove it's there, but no one's ever seen an electron. But we have seen protons and neutrons, and one of my favorite pictures from maybe in the 70s was IBM, which has some really cool engineers. They spelled out IBM with like 25 atoms of helium and took a picture of it. So there's a picture out there of IBM, the letters IBM spelled with like 20 or 30 atoms of helium with electron microscope at a gazillion magnification. Okay, but just to let you know, think about this. Everything has the same shape. So in nature, we like to think of the randomness and the variety we see of life, but there's really method to the madness. There is unbelievable God created, I think, complexity built into the system like this. So everything every atom looks like this at the subatomic level. Okay, and all we're doing every time we go up a periodic number is we're adding a proton and an electron. Okay, and so guess what the lightest element is? What's the lightest element? Helium, hydrogen. And that's why it's a gas, because it's so small. What is the heaviest one? Well, down here at the bottom, 92, I think, is uranium. And y'all have all seen the movies when they carry those nuclear weapons that are the size of a suitcase, and like 5 big men are carrying it because it's really heavy. Uranium is very heavy. And so it's a solid. And as we come down these first few are gases, then we come into solids. Okay? So there's method to this crazy madness. Okay? All right, so I would normally draw a hydrogen would be 1 proton, doesn't even have a neutron, and 1 electron in the first shell. Helium has 2 protons, 2 neutrons with a weight of 4. And by the way, this isn't a good periodic table. A lot of them will have atomic weight under here, right? So this is kind of like a cheesy one. I think the back of the book, there's one with weights on it. Now, let's talk about, and let's go, I'll stay with the PowerPoint. I'm going to come back to this reactivity in a minute. Now, let's talk about shells and orbits, okay? Now, here's the deal. I am a fat person. I have a large, I'm wearing like a size 42 belt. I'm looking up here, and I'm going to pick on Megan. I taught Megan's mother and daddy and both of her sisters, so this is a privilege to get to teach Megan. Megan is a legacy student of mine, and I'll pick on her because I know that her mom and dad will not mind that, and she seems like a really sweet young lady. So I said I didn't know anybody else. I lied yesterday. I do know Megan. Megan is a very beautiful young lady. I say she probably wears about a size 20 belt, okay? I mean, she has a very small, waist. So what is the difference between Robin and Megan? Robin has bigger girth. The bigger the shell, the bigger the what? The orbital, right? Y'all get that? So in other words, as we make bigger atoms, the orbitals get bigger. So they can hold more electrons, okay? So the first shell, and by the way, look, the people go, why? I cannot answer this one. This is one of those God things, okay? The first shell holds 2, and that's just the way it is, okay? That's the way God made it, okay? The second shell is kind of interesting. It can hold 8, okay? Now, here's where it gets cray-cray. The third shell can hold 18, but it really likes to hold 8 and is happy. And so I was watching, this is 15, 20 years ago when my oldest was watching Barney. How many of y'all remember Barney, the purple dinosaur? Y'all said y'all watched some Barney? So I'm watching her watch Barney, and I'm struggling with how to explain chemistry. And then I watched her, and by the way, I took her down to Disney, to Orlando one time, to the Universal Studios, and they had a thing like the Soda Coliseum, about as big as the Ole Miss Tad Pad or whatever. And you go to a Barney concert, and we waited in line, and she got to meet Barney, y'all, and she peed in her pants when she got to meet Barney. Funniest thing, I had to go wouldn't change her clothes because she met her hero. Okay, I don't know if I met my heroes, okay, but she was so pumped up about that. So I stole Barney on my theory on chemistry. Here's what I call it. I call it Mr. Robison's Barney rule of chemistry. And all atoms want to do is be happy. Okay? And y'all know the story, right? I love you, you love me, we're happy. Lord knows America needs some Barney today. Okay? We need a whole bunch of Barney, okay, in our country. And that's all I'm going to say about that today. It's my job to teach biology. Okay, now if we all agree with that, then we need to just define happy in a subatomic world. Then you would have learned the most difficult thing in chemistry, and you remember a Barney song to help you remember it. Okay, here's the deal. I'm going to say an atom is happy if it has a full outside shell of electrons. If it can get to 2 or 8, and this is 2 in the first shell, 8 in the second shell, or 8 in the third shell, then it won't screw with anybody, it won't try to steal anybody's electron, and it won't try to give nobody no electron. It will be happy. Okay? Now I am not happy in this country today. I need some Barney, I need some full electron shells, okay? All right, now if that is true, go with this. Now follow me on this. Then if that is true, if hydrogen has an atomic number of 1 and it has 1 electron in its first shell, is it happy? No. It wants 2. So when God created the universe, all the hydrogens laying next to each other grabbed their 1 electron and said, let's share our electrons. And that is why most of the hydrogen in our universe is either as water or as H2. You can't go to the welding supply company at Batesville and get a tank of H. You go down there and say, I need a tank of H, and they're going to call the FBI and the CIA, and you're going to be waterboarded later tonight. Okay? They're going to come to your house. But if you're a farmer or you're working church camp, or my dad and we had welding stuff, you can go buy a tank of H2 all day long if you have a reason to have it. But if you shoot an H2 tank with a rifle, I suspect it would be a very big explosion. Because hydrogen is not happy, and I got one word for you, and I don't have time to show you this, but in regular class, I'd probably show this video. Go Google Hindenburg sometime later today. That was a German airship that came over to America in the 30s or whenever it was, before World War II. And as smart as those Germans are, and they make some great cars, dude, let me tell you something. They had way better tanks than we did in World War II. But you may tell you what they didn't do. They didn't know how to isolate helium. And their airships were hydrogen. And that Hindenburg was landing in New York City right about the time Edison developed film to make photography. And there's a video, one of the first videos, well-publicized video, was that Hindenburg trying to land, and somebody dropped a wrench or something up there, and a spark occurred, and that whole thing got happy in about 8 seconds. All them atoms of hydrogen grabs an electron from the air, and that's what we call an explosion. Okay? A nuclear bomb is a whole bunch of atoms getting happy real quick. Okay, we don't want. So watch that Hindenburg burn, and maybe 120 people, I forgot what it was, died, and it was the first tragic accident ever filmed. Okay, and it's the Hindenburg. And the problem was they had hydrogen instead of helium. When you go to a sporting event, hopefully someday we'll be able to go to a sporting event, and the blimp comes over, you know, the Goodyear blimp or whatever, it is full of helium. At Walmart, when you get a little balloon and your kids get helium, helium is atomic number 2. It has 2 protons, 2 neutrons, 2 electrons, bing, 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 happy. And it cannot hurt you. It cannot do anything but float. But if you breathe it, you sound like Donald Duck. And if you breathe it for 8 minutes, you're dead because you died of lack of oxygen. Okay. I actually I got a weird story here on this real quick, but this is kind of sad. But I treat my coworkers like family. I've got to know most of them really well. And one of my coworkers had a roommate that killed themselves. And this was at college, and the person was brilliant. And she tried to find the best way to kill herself, and she actually got hydrogen and put a bag over her head and filled it up with helium and killed herself with helium. And you just go to sleep. And I know, and by the way, don't ever, and I'm not trying to tell you how to hurt yourself. Please call me, call a psychiatrist, get some help, call a doctor, call your preacher. Don't ever do that. That's not an answer. That's not a good choice. But helium would be an excellent way. Somebody should write a novel about somebody being killed with it. Because if you put somebody in it, fill them up with helium, and then take the bag off, the helium cannot bind to the human body. They would just show up as dying of lack of oxygen. Okay? Okay? And I hate to even say it, but just like Mr. Floyd, right? That was. I don't care if he choked. The man was killed by the cop holding down, right? I mean, lack of oxygen, whatever, heart attack. It was still wrong, you know, in my opinion. Okay, sorry, but I can't help but say that it was wrong. There's no excuse for that. Okay, sorry. That's just where I stand on that. But think about that, because we're talking about that today. Oxygen. You got to have oxygen, right, to live. Helium. You cannot live with helium. Helium will kill us, but it won't bind to the body. Matter of fact, I tell this in class. There's nothing you can buy to eat at Walmart that don't have hydrogen on it. There's nothing to eat at Walmart that has helium on it, because helium won't bind to nothing. Helium is an inert gas because it's happy. Hydrogen, bind to hydrogen, is kind of like a couple about to divorce. It's unstable, but it's kind of holding together barely, right? But it's very volatile. Okay? And that is a type of bond we're going to talk about called a covalent bond, where you share electrons, right? So sharing electrons is covalent. So H2 is a covalent bond. Okay? That help a little bit, make a little bit of sense. So atoms bind together by sharing or stealing electrons, as we'll see in just a minute. Okay? Now, just for a little bit of fun, guess what the next atom that is stable, that's called an inert gas, come down right below helium, and it's neon. Now, neon will not bind to anything, and the only thing we can do with it is put it in glass tubing and electrocute it, and it glows, and that is neon lights. If you ever been, and I really hope y'all, look, I have never been to Europe, and I want to go someday, but I want to see America first. I'm kind of pro-American, and I've been to most of the national parks, and I've been to Hawaii last summer. I want to go to Alaska. But if you have not lived till you drive through the desert and drive up on Las Vegas, let me just tell you, that is one of the great man-made structures you've ever seen, because you're in the middle of nowhere, and all of a sudden, bam, neon lights. Okay, and so it really is fascinating to see that. There's in New York City's to be seen. I'm telling you, it's a man-made wonder of the world, New York City. I'm telling you. But anyway, I've been there. But trust me, neon does nothing but glow when you electrocute it. Okay. Next one under it, number 18, is argon. I actually used to have a tank of this in lab when I did research. You use argon to clean surfaces because it is an inert gas that cannot bind to anything, because it has 8 electrons in its third shell. And by the way, as you go down a row, you're going down a shell. So every row is first shell, second shell, third shell, fourth shell. There's a method, and as you go left to right, you're adding a proton and a neutron to that shell, to that atom, to make that atom. So there's a real cool method here in this. I tell you where you've seen argon. How many of y'all seen Terminator 1? One of the great movies of all time, right? You know, I will be back. Okay. You know, or maybe it's 2 when they making that. Maybe it's 2 when they're taking that computer chip out and they close the room down to put the fire out, and that gas comes in. Argon is used to put a fire out because it sucks all the oxygen out of the room, and there can be no fire where there's no oxygen. So argon is used as a gas to put a fire out because you got to have oxygen to have fire. Okay, is that not pretty crazy? So it can be used for that, but it has a smiley face on the tank, y'all, because it won't bind to anything. And of course, the next one, we don't have time for this, but look at 36. I ain't got time to go into, we all know what Krypton does, right? That's what knocks Superman out, right? That's a whole nother story, right? So we want to get into that. But that is, man, you know, Superman, kryptonite, bad news. Okay, all right. But anyway, a little joke there. Okay, so now we kind of gone over that. And like I said, I don't know, but look, let me tell you, 8 is a very important number to God and nature. 8 is just what it is. 8 is stable. And I'll give you one more metaphor on this. Think about this. Most of y'all have probably driven a really bad car. Have you ever driven a car that had a unbalanced tire and your car vibrates? Okay, that would be like 7 electrons in a shell instead of 8. Okay, and 3 would be like, I used to have a car that wouldn't get, and this is why I speed when I drive, and I apologize. But my first car, you had to do about 80 to get it to come down. It would just settle down at 80. But 55 and 60, it was just going crazy. And then you get about 80 and it just kind of smoothed over. Okay, and that was my excuse. That's still wrong. It was illegal, and I sinned doing that, no doubt. That was a sin. Okay, speeding is a sin. Okay, anyway, was that not pretty cool? So to me, I call it Mr. Robinson's Barney rule of chemistry. It's actually a rule of chemistry called the rule of octave, which says that all atoms form 8 electrons in their outer shell. Okay, but I kind of stole it because I think the Barney metaphor helps me. In other words, all atoms want to do is to get a full outside shell, or they will either steal or share them. And that leads to our 3 types of bonds that we're going to talk about, right? And y'all may have heard these before. Covalent is sharing, ionic is stealing, and then the third one is called a hydrogen bond, which I'll go into in just a minute. Okay? Everybody cool? So let's take a second here. Let's take just a second. Is everybody okay with that so far? Did I help anybody? Did anybody have a revelation of some sort? Because I think that's one of my better metaphors I've ever thought of over 30 years of teaching, was this whole.
So does it have to fill just one shell for it to be considered happy, or does it have to fill all shells for it to be happy?
Okay, what they do, they fill in order. Okay, so the first shell fills, okay, and then you're happy. But if you get 1 in the second shell, you're not happy until you get what? 8 in the second shell. So they fill up sequentially. Yeah. And the third shell will actually get to 8 and start throwing them out to the 4th. And that gets into transition elements that we don't have in our body, that I'll say that for chemistry. Oh gosh, I just made a mess. I poured water all over my desk. Darn it. Oh, Robin, way to go. Lecturing in my office is not going to be good. Y'all missed a good spill there. You got me excited with that statement there. I just knocked over a bottle of water. Oh, wow. Good stuff. Oh, well. You got me. There's a good point there. Hold on. All right. Note to Robin, keep water away from arms when I start trying to teach with my arm. You know, I needed to clean my desk anyway. Thank you. I just cleaned it for myself. That helped me clean my desk. But no, sorry about that. But I do teach from my arms. I missed that. Okay, so yeah, so keep that in mind. They fill up in order, okay? And I'm not going to make you draw no big atom, but just know that the first shell fills up, and then let me go to this. So basically, the first shell fills up, and then you go to the second shell, and then the third shell gets to 8, and you go to the 4th shell. Okay? So yeah, it's kind of wild, Sorry about that. Well, I just had a glass of water. I just soaked some notes. Or with my handouts, some of my handouts for 11 o'clock. I'm going to be running some more stuff off. All right. So let's go a little bit farther. So here are the main ones that make up our body. We've already seen that. And we'll draw water in a second. Water is real important because water is oxygen, which has 8 electrons in its shell. That means it has 6 in its second shell. So it needs 2 to be happy. Okay, think about that. Let me see if I can draw that. Let me try this. I'm going to try this. Oh, never mind. I'm scared to draw anything now. I done kicked over some water, but I can make a pen here. Let me try this. And y'all may laugh if you choose. Okay, I'm going to try to draw. This may be a bad moment. Okay, so oxygen has 8 electrons. Okay, now watch this. I'm going to do it. The first shell is going to have 2. That's my 2. Boy, and the second shell is going to have 6 electrons. Now that's not happy, is it? To be happy, it needs what? 8. So yeah, it needs 2 more. That's right. Very good. Thank you, Ms. Gonzalez. Okay, now watch this. So when God created the universe, hydrogen is sitting over here, what? Not happy with what? With 1 electron. That's my E. And another hydrogen, also not happy, had 1 electron. So does anybody see a really cool fit here? If these guys share electrons, then you have what? Water which makes up like 70% of the surface of Earth, which is the most important molecule in your body. So water ain't no accident. It is God designed molecularly somewhat stable. Okay? And so when you draw water, you never draw it in a straight line. You draw it like this. Oxygen and the hydrogens are like this. Because they actually, and here's why this happens. This guy has 8 protons. These have 1, right? Who's going to win that tug of war? This guy. So this side is negative and this is slightly positive out here. And that's going to set up our covalent bond. So it makes it kink like that. It's not a straight line. It's not an equal sharing. Like, for example, I know Sean is married. Sean, I know that your marriage is not equal sharing. I know that you carry 75% of the work and your wife carries 25%, right? As most marriages are, right? I'm sorry, that was a joke. Okay. In other words, there is unequal sharing. Hopefully all your marriages are what? Equal sharing, right? But in nature, water is not equal, so it kinks like that. Okay. That's going to come back in a minute. But does that help a little bit? I mean, I know, sorry for my drawing. I've got to do a better board. But that's the deal. That's the punchline. Everybody's trying to get happy. And so water's pretty stable until you boil it, right? And then when it gets to what? 212 degrees Fahrenheit, all hell breaks loose and you get boiling water. Nobody saw that coming. Do you understand how cool that is? Nobody saw that coming. I wonder about these levels of carbon dioxide that are going up. I wonder if we reach a level all blank's going to break out again. I wonder about that, right? Because nobody, you just think about that. Boil water. Who saw that coming? I did not see that boiling reaction going to happen, but it does because of nature. Okay. So anyway, those are the elements we're made out of. And by the way, just FYI, I was a human body. I told you my degree was in human body. I'm all about human. I started teaching here 29 years ago, and I had to teach botany and biology. And I'm like, I don't know anything about botany. Now I did go back to grad school and get work 3 or 4 years in plant physiology. So I do know a little bit about plants now, but back then I didn't. I'm telling you something, man. I'm a closet tree hugger. Guess what the main component of plants are? Yeah, this stuff right here. So you are what you eat. If you want to live a long time, become a vegetarian. If you want to be happy, eat steak like me and Sean. Okay? But if you want to live a long time, eat vegetables. That's what probably God intended us to eat. It's not going to kill you. It doesn't have any fat in it. And fat is what's clogging my arteries. It's probably going to make me have a heart attack in the next 20 years. Okay? But that's my choice. That's how I choose to die. Okay? And keep that in mind as you grow up. Okay? So here's a couple of weird things. I'm going to hit this real quick because I don't want to waste your time. This will just be a point or two. Some atoms have extra protons, extra neutrons, and those are called isotopes. And y'all know, hydrogen, the most common form of hydrogen is 1 proton, one electron, has atomic weight of 1. But the tritium has actually a weight of 3, and it has 2 neutrons in it. And so here's the deal. All the atoms have their normal state, but a lot of them have extra neutrons that make them unstable. Tritium is an unstable form of hydrogen, and all unstable atoms usually give off subatomic particles that spew out, and that is radiation. So y'all learning something. Radiation is unstable atoms that have extra neutrons in them, and they spew out radiation, and eventually they become another atom. Okay? So they actually transition from tritium maybe to deuterium or to regular hydrogen. And so we use this in medicine to do x-rays, but we also use it in medicine to do what? To kill cancer. Because these particles coming out of radiation, which I won't go into, there are 3 types of those, they are really good at killing cancer. Okay? So that's kind of cool. People always ask, so an isotope is an atom that has a different atomic weight due to extra neutrons, and in some cases it's unstable. Now the reason I go over that, because if you look at a real periodic table, it says that hydrogen weighs, instead of 1, I told you it weighs 1, a really good periodic table will say 1.0037854, some random number. That is the weight of all of them averaged out. Because you throw tritium in there with a weight of 3, right, that's going to make the number go above 1. Okay, so when you're looking at a periodic table and you see numbers, atomic weights that don't seem like are not whole numbers, that's taking into account that some of those atoms have lost electrons. Like oxygen, I think the weight is 15.999, because some of them have lost an electron. So isotopes are atoms that have the same number of protons and electrons, but have different neutron numbers that make them unstable. Now, let me give a good application. what about 10 years ago, they had a nuclear reactor meltdown in Japan, right? It spewed radiation all out into the environment, into the water. Within a month, they were getting vegetables in the local stores that had radiation in them, because those elements were taken up by the plants and put into the strawberries and bananas or whatever. Because here's the deal: your body and no plant living organism knows the difference between radioactive carbon and normal carbon, or radioactive iodine and normal iodine. Because what determines how reactive an atom is Robin's rule of chemistry, the number of electrons in the outside shell. So reactivity is determined by those Barney rule of chemistry. How many electrons in the outside shell? If you're full, what? Or 8, you don't bother anybody. You don't bother to nobody. If you're not happy, then you're going to do what you got to do to get happy. And that means hopefully you will share electrons, but sometimes you will what? Steal or give up electrons to be happy. Is that not the coolest thing ever? So really, it makes there's a lot of method to this madness of chemistry, okay? But I just had to mention isotopes because that throws a lot of people off. So you don't want to be exposed to radiation because your body won't know it's not dangerous, and then it will kill you or hurt you. One of my best friends in kindergarten, and then we became friends again in college. His daddy was a doctor, and his granddaddy was a doctor during World War II. He was on the ship that went into Nagasaki and Hiroshima after we dropped a nuclear bomb on Japan cities to stop that war. And I have no problem with that. I'm not going to judge what they did. I'm just telling you that as a doctor, he went in there to help those people. And they would look at little boys like 8-year-olds that had nothing wrong with them physically, and they were dying internally and would end up dying. And that's when we discovered that radiation kills people. Okay. Y'all may not know this, but when we fired the first nuclear bombs out in Arizona, we took troops, American soldiers, and went there and camped out at ground zero for a month because they didn't think there's anything wrong with it. You know, they didn't know that radiation in the air, the elements had been altered, and they would kill you. I read somewhere, I may be wrong. I think John Wayne may have been one of those troops that actually went in there and camped out as a. I think he was something in, or maybe he was when he in the army. I don't know. I thought he was in the army at one time. But anyway, but some pretty famous people died later of cancer because accidental exposure. Because you don't want to drop a bomb on a town if you can't occupy it, right? Well, we're not going to be in Chernobyl for another 100 years, right? Where Russia had the nuclear meltdown, and Japan also had a lot of problems with that one, right? Anyways, it's kind of a neat story on that. So radiation is good and bad. In many ways, it can be used for good, but it is also quite scary. Here, X-rays, radio tracers, and it's actually used to kill thyroid cancer. If anybody here knows anybody who's ever had thyroid cancer, one of the treatments they tell you, go in a room, drink a glass of radioactive iodine-131. All that iodine goes to your thyroid, it kills it, and then you quit making too much hormone, then your body comes back to normal. Then you have to take the supplemental hormones the rest of your life. When they do this treatment, they tell you to go home, stay in your bedroom for about 2 weeks. Don't touch anybody, don't hug anybody, collect all your poop and urine and bring it back to us because it's radioactive. No joke, no joke. Is that not crazy? Absolutely crazy. But anyway, this thought y'all might find. So this can be treated, it can be used, but it's also can be quite dangerous. Okay, now let's go into it a little bit more and look at some of the molecular stuff of it. Mixture, I'm not real crazy about suspension. Blood is a suspension, meaning the things can settle out. Colloids are like milk is a colloid, so milk will not settle out. And you can see how it holds things together. Small particles will not settle out. And the solution is something that holds each other using those bonds. And so water has a charge to it. And we'll talk about that. Water is going to have this hydrogen bonding. And so you ever wonder why your regular Coca-Colas don't settle out, right? Like, okay, let me give an example. How many of y'all make tea and pour sugar in tea? What happens? The sugar goes to the bottom, right? Because because sugar doesn't have a charge on it. But when grandmama makes regular tea and she puts the sugar in the hot boiling tea, it breaks the sugar down into ions, and those ions go in solution, and water holds it, a la Mississippi sweet tea. So sweet tea, you have to you have to make the sugar have a charge on it. So ions go into solution. Those that don't have a charge will not go in solution. Fats have no charge. Fat and water don't mix. So, vinegar, oil, and water, salad dressing will never go into solution. It'll always separate out. Okay? Now, here it's talking about sharing. So hydrogen, and here's our first bond, a covalent bond, where 2 hydrogens share the 2 electrons. So they're circling like my little pen is doing here, but they ain't happy. They'd rather have their own 2 electrons, right? Okay? And so here are Methane gas has covalent bonds. Look at that. Oxygen has 2 covalent bonds, so it's a little more stable than hydrogen, right? Remember, hydrogen had what? 1 pair of electrons. So I always say, blow a room up. Has anybody ever seen the oxygen tank go off? Has anybody ever been to the hospital where they tell you to not smoke around Uncle Billy on a respirator with oxygen? Would you like to know why? It will burn like an acetylene torch. Yes. One of the worst things I ever had heard was we had a boy in town who just actually happened in Saratoga about 15, 20 years ago. Granddaddy was at home watching 5 kids or something, and he was smoking with an oxygen tank. And he lit his oxygen tank, and they said it was blowing like a blowtorch. And the oldest child was like 13. He couldn't put Granddaddy's bed out. He got everybody else out of the house, but Granddad burned up in the house. But he got all his brothers out and cousins and stuff. It's a terrible story, and pray for that family. But that is, you don't smoke around oxygen, people. Don't smoke around grandmother that's got an oxygen tank, because that thing is flammable, right? Because you can't have fire without oxygen. It has 2 electrons shared for 2 covalent bonds, but it's not real stable. And then nitrogen is in triple bond, so it shares 6 electrons. See right there, look, those electrons are all going like crazy. Now that is very, very stable. Let me give you a great metaphor here. How many of y'all know what air is? Y'all know what air is, right? We're breathing air. Air is 80%, man, I cannot draw with this, and about 20% oxygen. Now let me tell you something, guys. I don't want to get all on y'all. I'm not going to preach any more on this, but I'm going to preach real quick. If you don't think what we got on planet Earth is special and divine, let me show you something really crazy. Air is 80% nitrogen, which will not burn, very safe gas, 20% oxygen, so that our ancestors could come out of a cave and take a tree and throw 2 rocks together and start fire, okay? Fire is good. Fire cooked meat. Fire became electricity. Now look, this is because I got to make it something y'all can relate to. Electricity allows for our cell phones. Oh my God, you got to have cell phones, right? That's when girls start jumping up and down. Like, I get it, okay? So fire is good. Electricity. You knock this down, watch. You make this 10 and 90, and we're still in a cave. We don't have fire. We don't have combustion engine. We don't have electricity. We're still in the cave beating each other with grandmama's femur. Booga booga. Okay? Now watch this. Watch this. Make it 60-40. And Sean, who likes to smoke a cigar every once in a while, goes out back his house and ignites the damn universe. The entire planet burns. They break into CNN. Life on Earth dies this afternoon. Senatobia just went up in smoke. Memphis is burning. St. Louis in 15 minutes. Everybody in New York, say your last prayers. Big old ball behind you burns. Go hug a tree. Let's keep that number where it's at. God is good. Universe is not always stable. We're going to find a planet one day that has that same mix, and there are probably people looking at us through a telescope just like we're trying to find them. I believe there are people out there, okay, or something out there. May not look like us, but is that not the coolest thing? Thank you, Lord, for 80-20. Now, I don't have time to do this metaphor. I'm moving on. But if you know anything about our space, NASA did not take air into space until 1968. They carried pure oxygen. And on a bad morning in Cape Canaveral, we stir-fried 3 astronauts testing the engine when they had a fuse blow inside their capsule. Neil Armstrong was not going to be the first man to walk on the moon. He was the second choice. Those 3 men died that morning because we didn't carry air into space. We carried oxygen. But every space mission that we've gone up since then carries a tank of air. Because air, you can put the fire out. And an oxygen fire, you're dead. Okay? And so always remember the basics in biology. They'll save you in the hospital. Always make sure a man's got oxygen. Okay? Because we can't live without it. And we need air. Pure oxygen can be quite dangerous. Okay? There's no rule of octave. I've already gone over that. That's Robinson's rule. Y'all can read this. I'm not going to read to y'all. I'm going to tell you my span. I hope y'all don't mind me teaching like that, right? But here's the same thing I just said. That's the rule of 8. And there is carbon. That's carbon dioxide. Look at that. So that's carbon dioxide, which is pretty stable, right? And by the way, everybody's happy. All the atoms are happy now because they have 8 in their outside shell. Okay? And there we go. There's hydrogen gas. Now, sometimes, though, we have to steal an electron. So if an atom loses an electron, it is said to be If it loses an electron, then it becomes positive charge, right? It's a cation. If you gain an electron, then you become negative, right? And you're an anion. So if my bank account is 0 and Sean grabs my credit card and puts a $1,000 debt on my credit card, my account is going to be negative, right? If he puts $1,000 in my bank because he loves me, then my account will be positive, okay? And so guess what happens? Ions are atoms that have gained or lost electrons. Is that not the coolest thing ever? So when God created the universe, atoms that could not get to 8, they said, I got, 1 electron, I'm just going to give it up to somebody. But if you got 7 in your outer shell and you can grab one, then you'd be happy. So ions are atoms that have gained or lost electrons in order to be happy. Okay, so check this out. At the creation of the universe, sodium, and you're not going to draw this on test, just look, 11 protons, 11 electrons, 2 in the first shell, 8 in the second shell, 1 in the third shell. 1 is the loneliest number. That's an old 70s song. Check it out later on YouTube. Okay. Chlorine has 17, 7 in the third shell. So what do you think happened when God created the universe? All the sodium laying next to chlorine said, dude, take one of my electrons and become a what? Become an anion, negative 1. And sodium give up an electron, and now it's happy because it got 8 in the outside shell, but it's +1. And an ionic bond is an attraction between a negatively and a positively charged ion. And that, my friend, is table salt. That's table salt. If you go out in the woods, you'll find salt in the woods, and that's naturally occurring element where when God created the universe, sodium give up an electron, chlorine grabbed an electron, and they're attracted. So opposites attract. Everybody with me? An ionic bond is a bond between 2 different elements, 2 different atoms that have opposite charges. So that's an easy one to me. To me, the sharing would be the Barney bond, right? Share electrons, but here it's stealing so that you become an ion. Now check this out. We'll take a break in just a second. Everybody has had Gatorade and Powerade and all that, and all these commercials talk about it has important electrolytes. Okay, let me just blow your mind. Electrolytes ain't nothing but them dead-gum 7 atoms that we need in our body with a charge on them so they solute solution in water. Gatorade is just sweat put back into water with some sugar in it and some orange flavoring. Why didn't I think of that? Because we need those elements, right? And we're just putting them back in. Now, when I was a kid, Gatorade came out and it tasted just about what dirt tastes like. And after 20 years, it's actually pretty tasty now, right? They finally got a flavoring that works. But the very first Gatorade was like, worst thing you've ever drank, okay? But when I was a kid, they would not even let you drink water in sports because you was a wimp if you drank water. So we've come a long way in the science of medicine and body, understand the body. So you must stay hydrated or you die, and you must replace these electrolytes or you could be in big trouble. Okay, let's do it. Okay, there's our sharing one. We've already done that one, sharing electrons. There's oxygen, there's nitrogen. Sharing is a covalent bond. Okay, now let's do one more bond and we'll take a break. The last one is called the hydrogen bond. Okay, now look at these covalent bonds. This is equal sharing. Nitrogen is equal sharing. See, everybody got the electrons the same amount of time. Carbon dioxide is nonpolar also, and so is methane. But when you look at water, water's got a problem. Water is polar. It has a charge. So this is what water looks like I drew earlier. Water has unequal sharing because look, the 8 protons here are going to hold the electrons. So this is negative out here, represented by this. And this out here is slightly positive. So there is a slight attraction here, right? Now it's not a +1, -1 charge. It is a slight attraction. And so when water see each other, they grab together like this. So a hydrogen bond is this weak attraction between hydrogen and a polar covalent bond, meaning not equal sharing, and somebody else in a polar covalent bond that has a negative charge. Does everybody follow that? That's a really hard concept to see. There is an attraction there. Okay, it's not covalent, or if it'd be -1 +1, but it's a weak charge. So the hydrogen bond is the weakest of the 3 bonds, but this is why when I just spilled this water on my desk over here, the water did not go up in the air, it puddled up. It did not soak everything on my table, it just soaked it right here. Seriously, pour some water or coffee on the table and watch it bubble up. That's the hydrogen bonds holding it together. Now, guys, look, y'all don't take me the wrong way, okay? Because I use shop biology, but everybody's tired, so sometimes I'll say something a little bit inappropriate. So I'm going to do that now. If I were to flatulate on the table right here, that's cutting the cheese, that's a fart. Would it sit there or would it go off in the air? It would go off in the air because it ain't got no hydrogen bonds, okay? Gases are not held together this way. Water, because of these covalent bonds, the hydrogen bond is super important. That is why water sticks together. This is why boats float. This is why you can swim. This is so important, this hydrogen bonding. But when you boil water, you break those bonds and you create water vapor that goes into the air. So boiling breaks the hydrogen bonds. Okay, now we're going to take a break out this. So I thought about this for a long time, and I thought about this. How can I relate that to you? Okay, now here are let's review three bonds. Covalent steel electrons form ions. You know, positive, negative, cations, anions. Covalent bonds share electrons. Hydrogen bond is a weak attraction between hydrogen in a polar covalent unequal sharing and another atom, usually oxygen, can be nitrogen. And that little attraction right there is the hydrogen bond. So I thought back to when I was in high school, which was last year for some of y'all. How many of y'all know that person that everybody loved in school, very popular, but nobody wanted to date them? Oh, okay, thank you. Okay, I was a hydrogen bond in high school. Every girl wanted to be my friend. There weren't but 8 people that had a car in my whole high school. I was one of them in the 10th grade. Every good-looking girl wanted me to take her to the movie and do all kinds of stuff. When I'd kind of kiss her, she'd go, I don't feel like that way about you. So I was a weak attraction. A weak attraction, right? Nobody else a hydrogen bond in high school but me. Oh, thank you very much. Making me feel good today. I feel special. Okay, y'all get it? So a weak attraction. It's that guy that you get to do your homework or to take you out to eat, but you don't want to kiss him. You don't want to date him. It's just, we're just friends. Okay, all right. So, because come on, man, in dating, opposites attract. We know that, right? Negative, positive, right? So I'm just joking about it. But think about it. Covalent, negative, positive. Weak attraction is hydrogen in this polar covalent bond. All right, let's take a quick break, and I'm going to clean up my mess a little bit more. Go to the bathroom real quick. And we're going to come back, and we got to cover. Oh, there it is. There's blood bubbling up. So see that hydrogen bond holds that drop of blood together. Take a quick break, and we'll get back into this. Man, I did make a mess in here. Oh well. Needed to clean my desk. If y'all have a question, y'all can ask it because I'm fine. I'm just going to drink a little coffee. I guess I could pause the recording since we're visiting here. That's a beautiful baby.
Yes, I have a question.
Yeah, go ahead. Yes, Sarah. Sarah, right?
Yes. Why can't metals form covalent bonds? Is that like an ionization thing, or?
Yeah, they just grab each other. Yeah. So and actually, when you talk about like rust and stuff, that's a natural event where they're just shedding electrons and stuff. Yeah. So you get the metals and stuff, and really most of our non-living things like metal and stuff are ionic bonds. Rocks are holding rocks together. So we don't do a lot of ionic bonding in the human body and living things. We're more about the hydrogen bond and the covalent bond. Good point. Yeah, so rocks, metal, steel, all that's covalent.
Thank you.
And I'm not, and like I said, that's way above my pay grade on once you get much past that, I'm not a chemist. I mean, I had that stuff a long time ago, but I'm not at all a chemistry person. I wish I've even thought about going back and setting through organic again. I'd probably love it a lot better now that I've taught for 20 years. to understand the real nature of what holds living things together. Organic is where we're going to get. Organic chemistry is the study of things made out of carbon, and life is based out of carbon. As we're going to get into that. This next part makes a lot more sense once we get into that. And then we skip a lot of slides. This is a lot of pictures. We're gonna make it on time today. Anyway, yeah, good questions. And y'all can eat too. I'm not gonna judge anybody, man. I see a couple people been eating a couple times. I actually done have my biscuit and egg early this morning. There's a lot of little weird stuff like that. I probably maybe shouldn't have talked so much about isotopes, but that's a cool thing to me. The isotopes and radiation. A lot of people don't understand that, and I don't. I mean, it's just kind of cool. Those are just atoms that are unstable because they have too many neutrons. They spew out the radiation.
I have a weird question about chocolate milk because I just made some and
I
we're on
love
break.
it. Shoot, that's a solution. Yes.
Yes, I was going to ask, so if the sugar goes into, the hot tea and it dissolves because it has a charge, how can syrups dissolve into milk when it's cold?
Okay, that one already has a charge in it. It's already charged.
Okay.
So here's the deal. Glucose. We're going to see in just a minute. Glucose, table sugar is a glucose is a disaccharide. Okay, and when you boil it, when you heat it, it breaks apart into fructose and glucose that have a charge. So Coca-Cola and Dr. Pepper has sucrose in it already that's charged. They don't use table sugar. Table sugar is the most common form of sugar we buy. But think about like a syrup is already in solution. See, syrup has a charge. It's really cool, right? When you think about it, I mean, I love the chemistry of cooking, right? I love those cooking shows and stuff. There's a lot of real basic chemistry here. And so really that's a great one. So I was raised on a dairy farm. I don't like raw milk, but I give me some Hershey's, give me some chocolate milk all day, right? So you put that in there and it goes in solution because it's made to do that. And they don't use a disaccharide to make Dr. Pepper because you'd get like a 7-Up, then a syrup at the bottom. Okay? So it has to stay in solution.
Okay.
Matter of fact, look, I'm a big fan of space exploration. We're worried about getting enough food to go to Mars and back. Because, even a can of Spam goes bad after like 8 years. So we don't know. We spend a lot of money trying to research how to make food last in a can, to travel somewhere. We probably will have to grow our food if we go to Mars and stay. Real big fan of SpaceX. They have plans to colonize Mars, and guess who's going to go? They're not going to take none of you young people. Y'all just have a bunch of kids with mutants, make a bunch of X-Men out there. They're going to get old people done through having kids and let them go make the place for y'all to come later. And we'll go there and die. I won't come back. So there's plans to take a bunch of 50-year-olds out there and build the hole and make y'all a radiation shielded tunnel to live in. Then we'll bring y'all out later. Pretty cool. Oh, Elon Musk is crazy though, isn't he? You talk about people. If you look at him, you don't think he's on the spectrum. You talk about people with disabilities. There's no doubt he's on the spectrum, probably, right? But he's genius. His first billion, did he do PayPal, Sean? When his first billion, he created PayPal.
That, and he's been financed to do so many things. He's in so much stuff, it's unreal.
Yeah. And of course, the Tesla. I haven't bought a Tesla yet, but maybe one day. All right, everybody about to get back. Let's get back at it here. Oh, here comes Michelle. Get y'all back here. Sorry about that technology. I'll get this technology figured out. I'm going to get rid of the planet Earth maybe and go to something else later. But I thought that was a good one for today, too. The water and all. Okay, guys, let's try to get, because I think we got about 45 minutes, and I'd like to finish this chapter. And I'm on slide 31, but it kind of speeds up once we get to the 4 organics. Okay, so this is just showing how water boils up, like bubbles up, right? It doesn't float off because of hydrogen bonding. Oh, I'm gonna follow my slide. Here we go. Just talking about bonding here. When you see formulas, the line sticks represent a shared electron. If y'all never seen this before, so when you see that stick means 2 electrons, 2 sticks, or 2 lines. A line means a shared pair of electrons. Now look at that sulfur, and we'll look at carbon. It has 4 in the outside shell. And we'll talk about carbon in a minute. Carbon's coming up in just a minute. Okay, now this next little part is not super important, just different types of reactions. Anytime you have a reaction, you have reactants and products, right? And you can have reversible reactions that can go either way. You have irreversible reactions like this one, carbon dioxide and water, it can form carbonic acid. That's actually reversible. Okay. And then they do a little bit of physics here. Energy is the ability to do work, capacity to do work. And so we got to make energy out of our food. We make ATP to run our body. And so, you know, you have potential energy. That would be a gallon of gas. Those Vitol cocktails that people have full of Litten, that's potential energy. When they threw it on a car and it blows up, that is kinetic energy. A rock on top of a hill is potential, but when you're standing in front of a car, you've experienced kinetic energy. Okay, so we have to have energy in our body. There, and here's some of the forms. We have chemical energy and molecules of food or gasoline. Stick a fork in a power socket. Don't do that. That's electrical energy, right? That we pay for to run our devices. And then mechanical energy, the energy to move a wheel on a car, a transmission. Reactions can either require energy, and those are called energenic reactions, or they give off energy like a fireplace is exergenic reaction. So reactions that take energy in are energenic. Those who release energy are exergenic. It's worth noting here that photosynthesis is an energenic reaction where plants take sunlight and make sugar molecules that we then eat to make energy for us to run our body. And so, guys, look, I'm a big vegetarian, but everything goes back to the sun because the plants make the sugar that the cow ate, that I ate the cow to eat that steak I had for supper last night. So the circle of life comes back to the sun, okay, and energy, usually. Some reactions break things up. That's catabolism. And y'all know a catastrophe, right? I mean, our cities are in a catastrophe now. People are tearing down the city. That we get our word catastrophe from that word. Anabolism, anabolic steroids build things up, build muscle up, build body, and build structures. So we tear things down, the biscuit I have for breakfast, and then I exchange it, and then I build up new Robin muscle with that biscuit. So these are just simple terms you need to know in your walking through biology and medicine. Okay, here's a exergenic reaction, releasing energy. Here's the exchange reaction. Here's a couple of terms that drive me absolutely crazy. And if I could have a time machine, I would go back and slap somebody. And I don't believe in violence. I believe in nonviolence. But when they did this in chemistry, they come up with a rule: if a compound receives an electron, means it receives electrons. It has gained an electron. That means you've been reduced. And guys, I need to lose weight and I need to reduce my weight. That is so we have a conflicting word use here, right? At Weight Watchers, reduction means to lose weight. In chemistry, reduction means to gain weight or gain electrons. Very disturbing. I wish we'd get that straight. So when you hear somebody talk about oxidative reduction reactions, these are reactions that are going to what? Remove electrons, oxidize, and somebody else gains those electrons, okay, and reduce. And we're going to take sugar and oxidize it and make ATP, and we're going to reduce those electrons down to water. We end up giving the electrons to oxygen, and we form water. And we'll talk more about that later. So oxidation reduction reactions are how we transfer energy from sugar into ATP. Now, guys, look, this is the flaw in this book. The energy is not going to be covered to AMP2, but energy is a big deal. And if this confuses you, flip over to the energy chapter and read it, because it's really cool to understand that we've got to have food to make ATP. And ATP is our currency of life. Just like you can get anything in this country. If you got enough dollars, well, cells have to have ATP to live. And by the way, all living things on Earth use the same energy, ATP. So you and the tree and the fungus between your toes all use the same ATP. That's really fascinating to me. Man, we got 4,000 currencies on Earth, but then really on Earth, there's only one currency, ATP. That's the currency of all life on planet Earth. And that's why you're kin to the tree, by the way. That's another story. That's why we're all kin to the tree. We're all kin to everybody. Every living thing on Earth is kin to each other. Let's keep that in mind. Okay. Okay. So anabolism, build things up. Most reactions require an activation of energy. You got to have energy for a reaction to occur. Think about this: to crank a motorcycle, what you got to do? You got to kick the kickstart. You got to have a starter motor. You have to. Everything has to have something to start it. Okay. So all reactions have to have. And so enzymes are what we're talking about here. Enzymes are very cool. Enzymes are usually proteins that catalyze, speed up reactions, okay? And so for every, matter of fact, just to make a long story short, You got 46 chromosomes. You have about 24,000 genes in your human body. Those 24,000 genes code for probably 24,000 enzymes that make everything about us. Okay, all living things, most genes probably make enzymes that make things in your body. So Robin is ugly because he had genes that made an enzyme that made him ugly. Megan is cute because she has enzymes. She got DNA from her cool mom and dad and made her beautiful. Is that fair? Is life fair? No, it's not. Life is not fair. We all have equal rights, but we are not equal. I'm the ugliest person on this screen right now. This is not fair. I demand justice, right? I'm the ugliest person on the screen. But we all have equal rights, right? So we're not all, I mean, everybody's got different combinations of stuff, right? That's what this is getting at here. Everybody, all enzymes need energy to activate, okay? And so what enzymes do is they lower the amount of energy needed to do this. And I've got a great example of this real quick. I'll do it real quick. Everybody in here has probably tried to make a fire before with charcoal, right? If you do not have any lighter fluid, how many matches does it take to light one charcoal briquette? Okay, well, I had a friend one time, I'm making this up, I don't know. Don't drink, it's bad for you. I've seen people ruin their life drinking. But if you were to get drunk, I'd like to know the answer to that. I'm going to say about 220 matches, then you light the charcoal briquette, right? About on you light a match, hold it, wait till it burns, light another one. At some point, you're going to light the charcoal. Well, guess what? Lighter fluid is a catalyst. All you got to do is spray it on the charcoal and you can light a fire with one match. Charcoal, lighter fluid is a enzyme catalyst. It's a catalyst. It lowers the amount of energy needed to start a fire. Enzymes in your body act this way too. They lower the amount of energy you need to have a reaction to occur. Okay? Now here's the part that's crazy. Enzymes are recyclable and they're not used up. Now they eventually wear out, and that's why my face is drooping and I got wrinkles up here that all you young people don't have. Because when you get old, your enzymes start to wear out, like that wrench, it finally breaks. But think about that. Enzymes are molecular lighter fluid that speed up reactions and require less energy to get things done. Okay, does that help a little bit? So enzymes are very important, and most of your genes probably code for enzymes. A lot of our diseases are when enzymes don't work right. Okay, or you get a genetic disease and you make an enzyme wrong. Cystic fibrosis is a real famous disease that occurs, now, not being ugly, but this occurs mainly on white people, okay, of a European descent, because somewhere in Europe we got an error in the DNA, and you make one of these little protein channels in your cell membrane for chlorine that is messed up, and you can't get chlorine in and out, and that leads to this disease that makes these people choke to death. They can't breathe by the age of 18. Average death, when I started teaching 30 years ago, was 18. That means you die, half these kids die by the birthday at 18. And I'm not a big believer in assisted suicide. Here's why. 5 years ago, Genentech developed a drug. Come to find out these people are choking on DNA. They took it out of our stomach. They made a drug. You spray this enzyme down in your lungs. You break down the DNA. You cough it out. Life expectancy today is about 45 or 50. Wouldn't that have been terrible if you helped your brother kill himself at 18 and then we found a drug the next week that made his life expectancy go to 45 or 50? No, we haven't cured it, but we know the problem. It's a faulty enzyme in making these little protein tunnels to get things in and out of the cell. Is that not cool? Chemistry, error in chemistry. Okay, and we'll talk about other disease, but that's one that y'all probably know somebody that's I've known somebody that's had that one. It's a terrible one. Okay. All right, enzymes are very cool, but they're also susceptible to errors in concentration affects them, temperature. Matter of fact, my doctor friend tells me the main thing we worried about with high temperature, once your temperature goes above 105, you start to denature or melt the enzymes in your brain. Has anybody ever gotten really sick and lost track of a day or two? Lost track of time? Yes. That is because you are starting to decay the enzymes in your brain that do memory. Yeah, pretty dangerous. Okay, so high temperature alters these enzymes. They start to melt. And I love that old commercial. Y'all probably never seen it. It showed an egg, and then here's an egg on drug, an egg frying. So imagine how an egg goes from yolky, snotty stuff to a plastic after you cook it. That is what happens to an enzyme after you denature it or heat it. And then it never works the same. And by the way, you can't ever take that egg back to that snot-looking stuff, right? It don't work that way. So once you denature a protein, that's usually it. Pretty wild. Okay, let's move on. Okay, moving on, nothing on that. So enzyme speed, there's a good little page on enzymes speed up molecular reactions, enough said. There it is. There it is. Lowers the amount of energy needed. There, see that? Lowers the energy. Enzymes bind to their substrate like a key fits a lock. So you can't go to Walgreens and go in there and say, I need some enzyme. That ain't gonna work. Every reaction works from one enzyme too. So you have to have an enzyme for that reaction. People who can't drink milk and eat ice cream have to buy lactose enzymes so they can break it down or they get really bad upset stomach, right? That's a good example of an enzyme that these people, and by the way, we're seeing now that people get my age and then they become lactose intolerant. So they quit making the enzyme to eat ice cream and milk, which is a tragedy. So enzymes bind and they make reactions occur, called the induced fit. Here's a couple of diseases that have to do with enzymes that don't work right. Tay-Sachs disease, SID, that's the bubble boy, the little boy that don't have any, y'all remember from the 70s that lived in a bubble because he had no immune system, okay? And here's another one, PKU, which I could go on for an hour on this one. This is made out of phenylalanine. This is a disorder where you can't break down an amino acid called phenylalanine. Guess what Nutrisystem is made out of? Phenylalanine. Look at the label on Diet Coke. It says, and that's weird, I can't get the Coke can right. It says, this contains phenylalanine. Oh boy. Oh boy, right there on the label, contains phenylalanine. So if you got this disease and you drink Diet Coke like I do, your brain won't develop properly as a child. They have a warning, anything that has NutraSweet in it has a warning because NutraSweet is made out of phenylalanine and another amino acid. Pretty wild. NutraSweet is 2 amino acids stuck together. It's sweet. It has almost no calories, so it's a great sugar substitute. Or is it? I think it's safe. But if I die of that, then y'all might want to back off the Diet Coke. So I'm the living experiment there. Okay, now I want to get, this is the last part of the lecture here that's really important. Okay, we talk about inorganic and organic. Okay, so this is really important because somebody always misses on the test tomorrow. Okay, and they get these backwards. Do not get this backwards. If you're a nurse and you get this backwards, you have killed the patient. Okay, organic means it is made out of carbon and hydrogen. It means it's made out of carbon and hydrogen, mainly carbon. Okay, inorganic is everything else. Now, everything else is important, but life on Earth is based on carbon, and here's why. Take a look. Carbon is atomic number, what is it, number 8? Now 6, what is it, 6? 6? Okay, now watch it, I think it's 6. Uh-oh, my pen's not working. I love it. Come on, baby. Okay, I was gonna draw it real quick, and it's not wanting to work. Okay, but look, let's do it mentally. 6 electrons, 2 in the first shell, how many in the second shell? 4. How many sides of a brick are on the wall of a brick are touching another brick? 4. The side up, the side down, the side to the left, the side to the right. Carbon, because of its nature, having 4 unhappy electrons, needing 4 electrons to be happy, happens to be God's perfect building block. Okay? Think about it. If you ever laid bricks, the brick touches usually the brick to the left, the right, and above and below, right? And that gives us stability. God's building block on Earth is carbon. And our big discussion question for 5 or 10 points tomorrow is going to be list the big 4 organic groups, what they're made out of, and what they do for me and you. Now we're going to do them. They're coming. It's easy, and there's a huge table in your book. Do not miss this 5, 10-point question on test. I'm thinking I forgot to put the 3 bonds on the test. Okay, I may make that a super bonus that y'all write down. For some reason, I forgot to put the bonds on test. But this is the 5, 10-point question. List the 4 big organics. Okay, now we know these because these were the food groups that you learned in kindergarten. Sugars, proteins, fats, and nucleic acids. Sugars, proteins, fats, and nucleic acids. Those are your 4 organic compounds. All living things on Earth are made out of sugars, proteins, fats. We're having a great time, man. Come on in, come on in.
Your background on so they can't see me. Okay, I'll lean in.
Here's my boss. Y'all say hi.
I'm Dr. Wiley.
Dr. Wiley. We're having a great time. Here's my son. Don't put water too close. I was doing one of my lectures and knocked it over. Isn't that crazy?
All right. Well, I'm gonna sneak out. I just was checking on everybody this morning.
I told him you're gonna come by. I bet for laugh. You come by and just see some students this afternoon.
That's right.
Take a picture and post that.
I will.
We should do that because I miss to see the students.
Absolutely.
Look, isn't this crazy?
This is awesome.
Look, this is teaching. Look, here's my PowerPoint, and they're asking questions, and we've had a great time. I really needed this. But we're covering been to do organics.
Awesome.
And we're rolling, and they're gonna test tomorrow.
Well, if y'all gonna test tomorrow, I need to get out of y'all's way. So, bye. Good luck, y'all.
Yeah, man. We go. Hey, Philip's doing great too up there. Hey, he's got one class before I forgot about, a night class. I don't know. You just make a call. We'll go whatever you say.
Now he wants 3 and 4 kids.
Okay, I'm fine with that. I mean, he understands that. Look, we don't need to work every night. Well, I think we can move them. I need to look if we can move them to Soda, but if they're all full, we might select May. But I think there's a seat somewhere. I just missed it. I was looking up there. I mean, okay, sorry. Okay, guys, isn't that cool? Appreciate her coming by today. That's awesome. All right, so is everybody with me? So organics are things made out of carbon, sugars, proteins, fats, nucleic acids, right? And on the test, you're just going to list those 4, tell me what they're made out of and what they do, and you know what they do, right? Proteins are movement, muscle, right? Sugars are, for energy. Fat is for stored energy around Robin's waist, and nucleic acids are DNA genes that we don't get much energy. We don't do that for energy. So that is information storage. So DNA and our DNA is the nucleic acids that we pass down to our children. Okay, so DNA is the genetic material. It's the book of life. Okay, now stay with me. Inorganic is everybody else. So we're going to do some inorganics first, and then we're going to end by looking at the big 4 organics. But everything we eat is sugars, proteins, and fats for energy. Okay, that is where we get our energy. But there's DNA in all of our food too. So we eat organics to live, but we need some inorganics to live. They're important too. Okay, and if I made you list an inorganic, you want to put these next ones. Do not put sugar as an inorganic, right? This is one of those major errors. Do not get these 2 confused. Okay, now here we go. So inorganics are things like water and salts, metals, like you were talking about, Ms. McDonald, all those metals, rocks and stuff, all those are inorganics. Okay, very good what you said earlier about rocks and stuff. Anything not living is inorganic, and if it came from living things, it's probably organic. Okay. And so organic things, organic compounds do contain carbon bond to hydrogen. Now look at this. Here is a hydrocarbon, and look at everybody's got hydrogen, and all the hydrogens have what? 1 electron shared, and carbon is always happy. Look, it has 4 shared electrons. So carbon is always happy in any time you see a molecular structure. Is that not cool? And we're gonna look at a bunch of these, okay? Now here's the most important inorganic. Look at that big old blue ball behind me. Earth is mainly 70% water, right? Covered by water. So water is super important. It's the main compound in your body. You have 5 liters of water or something like that. No, wait, excuse me, 60 liters of water. You got a bunch of water in your body. You are mainly water, okay? But it's inorganic. It is not to contain carbon and hydrogen, and there's no energy in water. We cannot put water in the car and burn it yet. Someday we might be able to break it down into hydrogen, oxygen, and maybe use it for energy, but it is not flammable. You can't burn water. We use water to put a fire out, right? Water is very important, but it's inorganic. Okay, it's the main lubricant, cushion. It evaporates. Blah 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 blah. Okay, now we use it as a universal solvent. It's the main component of your blood. Here is water. Look at all those ions in water. So things that have a charge dissolve in water. Okay, those are said to be hydrophilic. Hydrophilic means water loving. Hydrophobic things like methane or oil and fat, they have no charge, and oils and fats will not mix with water. So that's why when you get that oil and vinegar dressing, it separates out because it does not like each other. So you have to shake it up and eat it real quick. I always said sweet tea with cold tea with sugar in it, you have to stir it and drink it to get a slurry, right? To get the sensation of sweet tea because it's not in solution. Okay? All right, acids and bases, and this is a big one. I forgot we got this in the cover, so I need to do this real quick. Okay, so water falls apart when it's in solution into OH and H. And so pH is a measure of hydrogen ions. So if you take a liter of water and put it in a beaker like this, a small amount of that water breaks apart into OH and H. Now you asked how much, Robin? Well, here's what I'm going to tell you. 0.0000001 grams per liter of hydrogen exists in a normal pure glass of water. Okay? Now, watch this. There's an equation. I don't think it's in here. Let me see if it's in here. Yes. If you take that number, I just give you 1 to the minus 7th, 0.0000001, put it in a calculator, hit log, you get minus 7. Take the negative of it, you get 7. So pH neutral 7 is the pH of pure water. Okay? And pH is a measure of the hydrogen ions in solution. So pH is nothing more than the measure of how much hydrogen is in a solution. So watch this. So pH 6 is move the decimal place 1. Okay? 0.00000, not 6, but 5 zeros. pH 1 is 0.1 hydrogen ions per liter. So 0.1 hydrogen ions. So that's battery acid. Stick your finger in the battery acid and melt it. Water is 7.2. Oven cleaner is 13, 14. And that's a strong base. And base is clean too well. I really struggled with pH, guys, when I first saw this, because I think 7 is not a good number. To me, it would have made more sense to go from 0 to 20 and 10 is neutral, right? And for a long time, I thought somebody in England just was smoking crack and made this up. But instead, when I got to college, somebody showed me this equation, and this equation is the deal. Pure water has a pH of 7, a little over 7, because that is 0.000 minus 1 to the 0.001 grams per liter. And as you go down, look, to 1, you have what? More hydrogen over here, less base. And when you go to bleach, oven cleaner, you have more OH and less hydrogen. So pH is just a measure of the hydrogen ions in a solution. But a lot of people get confused about pH. It's real simple. It's nothing more than the amount of hydrogen, and the more hydrogen, the more acidic it is, and the less hydrogen, the more basic it is. Now, let me tell y'all, and I know I saw Miss McCarthy babysitting a baby or whatever. I think we talked about that. The most dangerous thing in your house is the oven cleaner under the sink. You need to move that. Oven cleaner is bleach, and it's about a pH of 13. And if you eat that, if you eat a box of borax or oven cleaner, it will dissolve your esophagus and your stomach and kill you. Okay. Now we're real good about putting flammables up and stuff, but oven cleaner is just as dangerous as some other things, as some drugs in your house. Okay, really bad story, real quick, and I'll move on. So I saw a video of this guy who was a drug addict, and he was like 25-year-old. I don't know what he's on, but he decided to kill himself, and he ate a box of Clorox, of oven cleaner, killed it. And then he had an inspiration from God that says, I don't want to die today. So he dialed 911. When they got there, he had dissolved his esophagus. His stomach was gone. They had to pull his gut out, y'all. Cut maybe a foot or two of his gut off, attach it to his throat, and run it outside right under his skin. He has to eat almost continuously because he has no stomach. And today, some companies and stuff, his job is he goes around to kindergartners, pull his shirt up, off, eats in front of junior high kids and says, don't do drugs. It's very effective. And you see the food go down. And he runs the bathroom. Don't play around with the oven cleaner. Very dangerous, okay? Very, very corrosive, right? Y'all know what I'm talking about. So if you ever play with that. So anyway, it's kind of cool. So pH, by the way, favorite biology term, you're going to know this. What is that? What is the, y'all better get this because y'all are a bright group. What's the H stand for?
Hydrogen.
Thank you. Yes, good job. The H stands for hydrogen. But in your textbook or online, when you look in a book, that P will be italicized. Okay, it will have a weird, font. Okay, now check this out. That word is Latin or Greek or one of those languages, I don't know. And it translates, the word is persons. Okay, now there's a big debate. When we wrote the book, I wanted to put that in the book, and they told me no because it's about 50-50 that the scientists are arguing about what that Latin word means. But the woman who was my greatest mentor at Ole Miss Biology, Miss Perkin, who's dead, she said this, and I'm going to go with her. She was the first woman biology teacher at the University of Mississippi. She was an amazing lady. She said this meant power of hydrogen. And that stuck in my mind for 30, 40 years. So pH means power of hydrogen. And it really is a measure of hydrogen, right? We know that for sure. But if you put power of hydrogen, you're going to get it right on my test, okay? Because pH, that little symbol means power of hydrogen. Is that not the coolest thing? So you learned something today, right? You can tell your parents something, and you can look real smart at the dinner table. pH means power of hydrogen. It's a measure of the hydrogen ions in a solution. And living things really like to be around 7, right? A lot of y'all gonna be nurses. Acidosis, if the blood falls too low, below 7.2, something like that. If it gets above 7.6, you have alkalosis and you die. So very important that blood stay right in this little range right here, that little range. Okay. Buffers are things that prevent changes in pH. Everybody in here has probably ate Rolaids, right? To neutralize the stomach acid in your stomach. Rolaids can grab hydrogen or they can release hydrogen. So they prevent shifts in pH. Acid rain is when chemical waste goes up in the clouds and it rains acid down. We have acid rain in North Mississippi, but we ain't gonna worry about acid rain killing our fish or our soils. Sean ain't gotta worry about sardines getting killed. Would you like to know why? How many of y'all walked in the mud and all that clay gets stuck on your foot? You ever had to clean your boots after going through the creek? That is Rolaids, people. That's Rolaids. That's calcium bicarbonate. It's the nature's buffer. Our water is very buffered around here. Our soil is buffered around here. Up north in northeastern United States and Canada, we have lost thousands of acres of trees due to acid rain. It literally killed the soil. But it rains here, but we have lots of buffer. I'll give you an example. How many of y'all been down to Florida and took a bath and the water didn't come off? It felt sticky. You ever notice that? That's the difference between hard and soft water. We have more buffers in our water than they have down there. That's just a little differences in the amount of ions in the water. Isn't that cool? But anyway, so buffers are really cool. They prevent changes in pH. A salt is any nonmetal cation and a nonmetal anion held together to form an ionic bond. There's your answer to Ms. McDonald. That's what metals are. So salts are when you take a metal cation and a nonmetal anion, you form a salt. So salts are just two elements stuck together. Okay. Now we're down to organics and we're going to make it. We got about 15 minutes, 20 minutes. But organics are now we're going to do organics. So all these elements that we found in like sodium, potassium, all that's inorganic. But only when it forms these bonds do you get sugars, proteins, fats, and nucleic acid. So the big question is, we are made out of organic compounds. Okay, the first one is, here's the 4 of them. And monomers is a single unit. They're all made out of monomers, right? Hydrolysis reactions use water to break polymers down. So we hydrolyze the food we eat, okay? And we're made out of sugar. Sugars are made out of monosaccharides, single ring sugars. Here they are. There's ribose and deoxyribose found in our DNA. Here's glucose. Here's fructose. Here's galactose. Those are monosaccharides. If you eat pure sugar, it's absorbed quickly. Gatorade, I think, has this in it, so it's quickly absorbed. It can be used for energy. Disaccharides are 2 stuck together. Here is table sugar. Notice no charge on sucrose. When you hydrolyze it, you have a charge on fructose and glucose. So they're charged, so they go in solution. So when you put sugar in hot tea, it breaks it down into these ions that go in solution. Thus the sweet tea thing. Anybody use the what is the the artificial sugar? The one that's got it says sugar. Oh my God, what's the other one? Not NutraSweet. What's the other one everybody likes?
Splenda.
Splenda. Splenda is a chlorine stuck on a glucose molecule with a charge. So it's basically glucose, sugar that you can't absorb, and that prevents your gut from absorbing it. Is that not cool? And it has a charge, so it goes in solution. So you can take cold tea and put Splenda in it, and it goes in solution. I use Splenda a lot. Yeah. Thank you. Splenda is a chlorine stuck on sugar. So these are the main energy source on life. Polysaccharides are hundreds of these stuck together. Glycogen is stored sugar in animals, in our liver. Starch is what we eat, is bread and biscuits and stuff. It is stored sugar in plants. But plants also can make cellulose that we can't digest. So if you're on a diet, everybody says eat all the lettuce you want. You lock me in a room with a ton of lettuce and 1,000 bottles of water, and I will lose 50 pounds in 6 months. You cannot live on water and lettuce forever. Now I've got 6 months of food on me, and Megan, poor little Megan, she's nice and thin. You know, I'm gonna have me some Megan kebabs in about a month or 2, right? She's gonna starve to death. No, we're not gonna do that. I'm picking on her. But what I'm saying is, stored energy, you're gonna survive a little longer, right? If you got a little bit of fat on you. But you cannot live off of cellulose. Another one that's kind of cool is chitin, is a sugar found in shrimp and the shells of our shellfish, like crab legs and stuff. You cannot eat crawfish or shrimp shells. It is chitin. Oh, you can eat it. It's just coming out, okay, violently. You can't digest it. Okay, so don't eat shells of shrimp and stuff. That's a bad experience. But on a diet, by eating lots of cellulose, lettuce, and other green stuff, then you get lots of fiber and you have lots of bowel movements, right, and everything's great, and you lose weight. So that's why people talk about that. But this is glycogen, and she didn't go into the book. Mr. Hammerman didn't show it, but there are pictures you can see that cellulose has a different structure. Okay, but we ain't got time for that. All right, lipids are fats, and they are high in energy. Now check this out. This is something you might like to know. A gram of protein has about the same energy as a gram of sugar, but a gram of fat has 3 times as much sugar as grams of sugar and protein. So there's more energy in fat. So if you need to lose weight, you should not eat a lot of fat. I saw this one time, it blew my mind. They had and I love these, I'm sorry, that McGriddle and McDonald's, you know, with the syrup and the biscuit and bacon and egg and all that. One of them laid out is like 700 calories. You can have about a pound of strawberries, a pound, I mean, literally a bowl full of grapes, same amount of energy. I've had one McGriddle, and you know what? I wanted another one because I'm still hungry. You eat a bowl of fruit and you're full. Think about that. And you get less calories. So volume is important, right, to fill the stomach up. But fat is what you want to avoid if you're trying to lose weight. Okay, now what is fat made out of? Now check this out. Fat is made out of fatty acids, which are long carbon chains, and a 3-carbon sugar called glycerol. Here it is. So here it is. There's glycerol and 3 fatty acids. Triglyceride down here on the left, here, right here on the right, excuse me, looking for my cursors, and I want to come over. That is the most common form of fat in the human body, triglycerides, okay? So it's 3 fatty acids and a glycerol. Fatty acids can be saturated, meaning they are full of hydrogen, or it can be unsaturated, means it has a double bond in it, and they have kinks in them. Now listen to this, this is really cool. Saturated fats, because they're saturated hydrogen, they pack real good like sardines in a can, and they are solids at room temperature, like lard and butter. And you want to avoid those, really need to avoid those. Unsaturated fats are liquids at room temperature, like canola oil and vegetable oil. And there are a few good fats, and we think canola oil and some of the seed oils are good for you, but you want to stay away from the most common fat in Mississippi, and that's pig butt lard that we cook everything with. It's the cheapest fat at Walmart, and it's probably why Mississippi leads the nation in obesity. I would say that any of y'all Northwest students already, some of y'all know Coach Cole passed away yesterday, yesterday. And that's so sad. One of the finest men I know. Not a better man ever walked on this earth than Coach Cole. He was our weight and condition trainer. And he was an African-American man who died, and he was 51, just died at 51 years old. So sad. He had a massive heart attack from what I've been told. He was super, I've seen him, there's a video of him deadlifting 250 pounds 100 times. He's one of the most muscular people I've ever seen, but he ate a lot of food too. So he was a little bit overweight too, probably, but he was very muscular. You can be obese and be in great shape. I mean, he was a weightlifter, power lifter. So sad to see him pass away, and my heart's broken thinking about him today. But one of the real heart and soul of our college that really loved everybody, totally colorblind as anybody can be. Coach Cole was that man, and we miss him so terribly today. Our flag has been half-staffed yesterday and today in honor of him. But we all need to back off of these fats, okay? Because this is what clogs our coronary arteries, and this #1 death in America is cardiovascular disease, and that is, you know, probably a lot of our fate. I mean, most of us will die from heart attack. That is the way we're going to go. That's statistically what's going to happen. So you want to avoid those, and you want to eat monosaccharides. Maybe think about Europe. They have no heart attacks in Europe. They eat more fat than we do. They eat the same bad. Their calorie intake is higher than ours, but they eat olive oil, and they fry in olive oil and other things. They don't use lard. Okay, stay away from animal-based lard to cook with. That is, I mean, it's some good fried chicken, but it's killing us. Okay, it is killing us in Mississippi. But it is cheap, and I think it has to do with that. That it's so cheap, people buy it. Here's another one here, polyunsaturated, that is man-made. These are made in the laboratory. They don't exist in nature. Some of these, we started to ban some of these. Now, here are the good ones, omega fats found in fish oil, flaxseed oil. Stay away from animal fat. Okay, big problem. And then these trans fats, those are the ones that have been made in the laboratory, and they're being banned now in restaurants. So this is a man-made fat. Okay, just like margarine. Y'all know margarine's man-made, right? Margarine. I don't eat nothing but real butter. Look, I learned from one of y'all. This really happened. About 10 years ago, one of my students said, Robin, do this. Y'all try this. Go get a stick of margarine and throw it in your carport in the corner somewhere where nobody cleans up. And take a stick of margarine and butter and throw next to it. The ants will tote the butter off and they will walk by the margarine. They will not eat the margarine. It will be there 6 months later. I've done that. Done it in lab before as an experiment. It's kind of scary. So I backed off of margarine. Just man-made. Butter, a little more natural. Okay? But triglycerides, this is stored fat. Cell membranes are made out of phospholipid. That's another fat that we make. So that's a kind of a cool one in the lipid group. And we got a whole chapter on the cell. We'll look at that. Phospholipids are cool. This is what your cell membranes are made out of. Very important. Steroids, I don't got time to have my lecture on this. Steroids are a group of fat made out of 4 carbon rings that look like cholesterol. Now listen, guys, this is one of the, you talk about, look, fake news has been going on long before the last 4 years, okay? Everybody has heard about steroids, how bad they are for you, and that is not proper use of the word steroid. In the world of fat, there is a little group called steroids. In the world of steroids, there are the sex hormones. Cholesterol and many other compounds have nothing to do with sex, but they're steroids. So when you got to, in your mind, when you hear the word steroid, quit thinking about Arnold, some weightlifter pumping it up with steroids. That is a steroid, testosterone. Estrogen is a steroid that makes women women. Has nothing to do, so we got to get that out of mind. And cholesterol is just the most famous steroid, has nothing to do with sex. How many of y'all have had cortisone shots? I get them in my knee. You go to Walmart and put hydrocortisone on a bee sting. That's a steroid. That's not going to make your baby turn into a girl, or your girl turn into a boy. It has nothing to do with sex. It's a steroid that we use all the time. So steroids are just a group of fats that happen to include the sex hormones, okay? And then they're made out of these little, they're made, and an estrogen looks just like this, just move some of the carbons around. So steroids are just a group of fat made out of cholesterol. And we'll talk more about that as we do our adventure. And so hormones made out of steroids go through the cell membrane very easily. And that is something we'll talk about later in A&P that's really important. Proteins are very simple. There are 20 different amino acids that make up all proteins. Here are 3 of them: glycine, serine, and cytosine. Okay, and I'll make it real simple. There are 20 different letters in the language of proteins. The letters that you put in the proper order, like R-O-B-I-N makes Robin, Heather is H-E-A-T-H-E-R, right? But in proteins, that sequence of H-E-A-T-H-E-R, not just as Heather's name, that makes Heather Heather. And R-O-B-I-N makes Robin Robin. So the sequence of amino acids are the difference between chicken leg and pork leg. They're both the same muscle, but they're spelled a little bit different. And I like both chicken and pork leg, okay? So all proteins are, the difference is the sequence of amino acid determines the protein. I've said this for about 15 years. Before y'all die, you will buy at Walmart a protein generator, because all you got to have is 20 different tubes and one of those 3D printers, and you can make Como Steakhouse ribeye. Our Sean wants some Vienna sausages today. He can pump it in and make himself a Vienna sausage, which I would think that's pretty bad. I think I'd rather have, rendezvous ribs. That's coming, people. Okay? Food generators for protein, because there are only 20 amino acids to make up all proteins. It's all got to be the sequence. Now, it's a little bit more trouble. What? And then we got to fold it. Then we got to fold it again. That's where that printer will come in. Then we got to fold it one more time. So quaternary structure is different proteins stuck together. Cystic fibrosis is a spelling error where one of those proteins don't fold right. And that causes genetic diseases. Okay? I mainly talk about primary level because that's real simple to me. So the sequence of amino acids determine the protein. Everybody cool with that? Everybody get it. So, and think about that. Protein in peanuts or whatever, the protein in it is a different spelling. It's all about the sequence, like a train with all the different, the different box cars are all different, but the sequence of box cars determines what their protein is. And we're real close to generating proteins in the laboratory. I mean, literally, the food generator is coming. Then we got to fold it right, and then we got to fold it again, and then we stick proteins together. And of course, heat are very successful. So when you fry an egg, you alter the proteins, and that's when they change and turn into plastic, feeling stuff. So when you denature protein, it can never go back to where it is. Thus, high temperature denature the enzymes in your brain, and that's why you start to go cray-cray, and you lose track of time. And so that's what happens with high temperature. Nucleic acids, we get very little energy from these, but these are about information storage. Nucleic acids are made out of nucleotides. They all have a sugar, a phosphate, and one of these 5 bases. And y'all know from DNA that the bases in DNA are adenine, guanine, cytosine, and thymine. And so the 4 nucleotides in DNA are adenine, guanine, cytosine, and thymine right there. And then RNA has uracil that we only see in RNA. So we haven't talked about all that. I know y'all remember that from high school biology. We're going to talk about that the next couple of days on chapter 3. But basically, now look, this is the craziest thing ever. These 20-some thousand genes we have are thousands of A, C, T's, and G's in a certain order that tell us how to make proteins. So you are who you are because the DNA and your mom and dad are mixing together, and that is expressed in everything we are. Okay? And I will tell you, man, that my experience, and I'll end this with something. I've really been quite upset about what's going on in our country. And I thought about posting this, but I will say this to y'all, that I've been teaching, this is 30 years here, and I've taught in Ole Miss for 6 years. And community colleges is working class people getting a chance to get ahead, and that's what I was growing up. And so I've dedicated my life to trying to teach people who are trying to make it better for their family, right? Most community college people are not millionaires like going off to Harvard or Ole Miss, from California coming out here to have fun. Y'all trying to make a difference in your life to improve yourself. And I will tell you, I'll put my hand on the Bible and on this biology book and tell you that I have never, I'll tell you, my professional opinion is that they just as many sorry people of every race as they are just wonderful people. And I have seen no difference in intelligence or ability in any different race of people. And we got to get past race, people, okay? And that's all I'm going to say about it. But I see everybody, I've seen brilliant of every people, okay? And we just need to acknowledge that there appears to be no major difference in our DNA to justify us thinking anybody is better than anybody. And if you believe that, then I'm so sorry for you if you think you're better than somebody else, okay? But I will tell you that the science is not there to back that, and I'll stake my life on that, okay? And I've worked with all kind of people, and there are good and bad of everybody, and I would say the percentages are almost identical, okay? But I will tell you, man, community college has some hardworking people because y'all had to work before. Y'all know, some of y'all know what work is, right? And so you've got to work hard, I think, to get ahead in this, in nursing. But anyway, isn't that the coolest thing ever? DNA is so cool to me. When I started teaching, we did not know. We thought there's 120,000 genes. We now know we're not as complicated as we think we are. There's only about 21,000, and we got viruses in us. We got protein. We got fungal DNA in us. We have got a lot of stuff going on in our DNA. And I have no problem us trying to clean it up a little bit, right? Because if you remember in the Bible, those people lived to be real old, right? Why don't we live to be 400 years? I can tell you what I think is our DNA's got polluted. And we may have the ability to clean it up, but we are not going to clean it up to eliminate anybody either. I'm not going to be a part of that. So I'm very scared about the future of DNA, right? But I can tell you right now that I've seen nothing that makes me think anybody is better than anybody else, okay? And I think that should be said today. All right, anyway, ATP is one of the nucleotides. This is our energy source. So it's made out of a nucleotide, and it's the key energy for life on Earth. And we're not going to have an energy chapter to Miss Dickens in next month. But ATP, look, when you take a phosphate off, that's how you do work. So every living thing on Earth uses ATP as their energy source. Is that not the craziest thing I can tell you? Okay, now one more thing, and we'll stop the lecture. We're about done. But let me break it down and let me lower a little bit farther. So DNA tells us how to make proteins. Sequences of this DNA tell us how to make proteins. And there is a secret code in the DNA that what all these A's and T's mean. So let me end with this. This will blow your mind. Matter of fact, if you were to ask me the most interesting biology fact I can tell you out of the whole book, here's my fireworks, here's the big one. About 20 years ago, we deciphered the DNA, the secret code in DNA, what all the letters mean. And we will see in the next chapter the coding that shows what the letters mean. They tell us how to make proteins. and proteins are enzymes, and enzymes do everything. Okay? Now listen, as soon as we broke this code, people immediately went, well, what do dogs do? What do rats do? What do bacteria do? What do fungi do? What do trees use? What is their code? There is one genetic code on life on Earth, and we're all using the same code book. There is no way that happened randomly, and there's no, and that is fact that we're all kin to each other. That all living things on Earth come from one common life source. Now we can argue about that one. I don't have proof about God, but I like to put God in there. But I'm okay if you don't believe that. I love you anyway. But I'm telling you, all life on Earth is kin to each other, and that proves it. That the secret code of DNA is universal on all life on Earth. So my question to end this lecture with you is, when we go to Mars and find life on Mars, what code do they have? If they have our code, they are brother and sister. If they got another code, then we got a new way to build things. We got a new way to make things. And I want America to get that code first, because that's a game changer. Because the cotton you're wearing, the wood in your house were made using that secret code. And there's only one code right now that we know of. What about that? Is that not crazy? I think I'm through. Let me see. I think DNA, nothing much here. RNA is, we'll talk about it. That's a nucleic acid that we copy the genes into. This is how we make proteins. We'll talk about it later. Nothing much here. And then we got a summary. Look, I always tell people this. Please don't do anything stupid. But if you do get like wasted for tonight and you wake up in the morning right before class, look at the tables. They summarize the chapter, right? If you wake up, fall asleep, and haven't got nothing to look at, the tables are awesome. There's sugars, proteins, fats, and nucleic acids. Great summary. All right, question anybody? All right. Hey, I'm not even going to call roll day. I'm going to call everybody here. I'm not a real big, my boss is gone. I'm not a real big roll caller, but I've got a big crowd of y'all. We still got to figure it out. We got 27 people here today. That's probably everybody's going to be in here. I really appreciate y'all's attention, and I hope I didn't get anybody too upset about anything, but I do feel that DNA is so cool, and we're going to get into that chapter 3. Chapter 3 is a great chapter. All right, so the test tomorrow, what I want y'all to do, we're gonna meet here. Let's meet at 9 o'clock. Is that okay? And we're gonna be in room 105, 104, first floor, and I'll be out there waiting. It's 105, 106, and 104. So it's on the first floor, 105, and I'm gonna put us in 3 classrooms. We got about 27. I'll put 9 of y'all in each room, and I'll just walk between the rooms. I have masks for y'all. I'm gonna provide your masks. I think that's great. Schools provide masks. I'm going to grade them, and I'll probably post them tomorrow night, and then I'll let you look at them after we take our next test. I got to figure out a way, because we're not, I'm not going to try to scan them and send them back to you, but you will get a chance to look at them, okay? All right, any questions? I know some of y'all got to get in the car and get on over here, and I understand. So I had somebody's actually zooming as we leave. Okay, big question is what? List the 4 major organics, sugars, proteins, fats, and nucleic acids, what they're made out of and what they do, okay? We're going to have 10 terms, and I've hit a lot of them already today. Okay, and then we're going to have why is carbon so important? Because it can form what? 4 bonds, and it's the building block of life on Earth, right? Stuff like that. All right, anybody else got a question before we get out of here?
What building is that in?
Math and Science building. Math and Science building. Okay, great, Ms. McDonald. Good point. I love you, man. You're helping me out. Y'all got to talk to me some. I appreciate you talking. Come down to Senatobia, come down 51, and when you see the school is on Highway 51, you want to turn right onto campus at Burger King. Don't turn in the city, but turn on Northwest Road. There's not a light. It's not a light. There's no light there. You just come past the 4-way, turn and come down. You're going west, and you'll see Walmart to your right, and my building's on the left that has Math and Science on the side of it. And I've unlocked that door. I was just parking that big parking lot right by Walmart. If anybody gets a ticket, I'll handle that. I talk to the chief of police. Don't worry about it. We're good. You can go get a permit if you want to. If you have time after lab, go ahead. They'll give you one free. You've already paid for it. You can go to the police department and get a sticker for the summer, but they're not going to write any tickets today. We're y'all are the first group to come on campus today. So we're excited in 3 months. Okay. That help? I got it? So this, and it's a map too online. If you get lost, go online, type in, Northwest Coliseum or whatever, because I'm really close to the basketball stadium. Okay, guys. Thank y'all. I'm really enjoying y'all. I'm hoping everybody just blows this test away tomorrow. I know a lot of y'all have not had a real college test, but this is kind of how we do things. I'm not going to give you the test, but I'm giving you a lot of it. But you got to go in there and dig it out. So y'all got to study tonight, right, and get those terms and stuff. But I suspect about 10 A's tomorrow is my guess. Okay, because I see it in y'all's eyes, and some of y'all been hitting it hard. Don't forget to go by and get your lab book before you come. And I'll start lab a little late if we have to, but go by and get that lab book, and then pick up the free book for $1. I mean, my gosh, give it to your little brother or whatever. But it's a loose leaf. You paid for it, and it's a deal. Nobody else got that deal because we were working for them around the lab book. So we kind of got a little insider deal there. You can get a free loose leaf copy for $1. So don't buy one online for $20. A lot of people buy them and try to sell them online. That's so wrong, man. Okay, but you got it already.
Where do you
got
get the lab book from?
The bookstore. Yes, ma'am. The bookstore.
Okay, where's that on?
Okay,
campus?
if you take that same turn I did and come past my building and come to a four-way stop, take a left, and it's right down on the left. You'll see it says bookstore. It's at the oh my gosh, it's at the Union. We have a big Union thing. I can show it to you. It's down there. If you come in off of Walmart, there's a way in. You go straight in, you'll see it. It's down on the left there. You might want to get that map out. I can show you the map later in lab if we need to. But there's a map. Just look it up on the map, the Northwest map. But it's very easy to find. He is working today. He'll be here to 3:30. Okay, I'll see y'all with y'all class, or y'all get on out of here.
Since I changed my lab to the 11 to 1 today, could I come to the 1 instead of?
Are you going to move to 1 o'clock? Or you want to move to 1 o'clock?
I want to try to move to 1.
Okay, who is that? Who is that? Raise your hand.
Carr.
Okay, let me find you. Say it again. Who is it?
Carr.
Rosalind Carr. Okay, yeah, I can do that. So I think so. Give you a little more time to get here.
Yeah, that'll give me more time to get here.
Okay, I'm gonna put you in 1:30. I got a seat in my 1:30. I'll put you in there right now.
Thank you.
I got the power here, man. I can do that. I can do that. And maybe, but one of them, I know we got a seat in there. We've lost a few students. That should be expected.
Okay.
People just didn't understand. We had a few people didn't know we were gonna have to meet in person. But it's really better for y'all. This is way better. I think the online with 2 tests is a lot more stress. You don't get to talk to nobody. I really think this is the way to do it. Okay, I'll see y'all later. I'm gonna cut it off. I'm going to put Ms. Carr in on afternoon lab. Yeah, see you at 1:30. We're in 207 and 209. Both classes are the same, 207, 209.
207, 209.
Mm-hmm. Anybody else? I won't cut off to everybody. Any other questions? William, question?
So I'm here at the library on campus. Where is the math and science building? Are you in there at the moment?
That's why you got a mask on. You're on campus. Awesome.
Yes, sir.
Okay. Let me think. Okay, so the library. Okay, what you want to do is go. Probably be the easiest way is to. You can weave through campus. Can you see Walmart? You know where Walmart is?
No, sir.
Okay. All right. What I would do is just come out and get back in your car and get back on 51 and come down to Burger King and turn right before you get to Burger King. And that's the road I'm on. So basically, if you go to the front door of the library, I am toward Memphis from you. Like toward Memphis and to your left. Now you can weave through campus, and actually the bookstore is over there. If you want to come on past the library, it weaves around. You can find the bookstore, but you can't miss my building. It's math and science. It's the only 3-story building.
Yes, sir. And are you on the second floor?
I'm on the first floor. Our lab is on the second floor. And by the way, there's some study areas on the second floor and third where you can go over here and go grab a sandwich, go sit down up there and eat. You can have a little break there. There's power for your computer if you want to just wait on us up there. A lot of people usually congregate on the second and third floor. I know we need to do social distancing, but there's room up there if you want to come on over here and find it. That way, you can grab something to eat, come on up here. There's tables to eat on here. And the cafeteria's open. Cafeteria serving food. They do a really good meal. I usually eat there a lot. I'm probably going to end up going over there after the first lab and eating. And if some of y'all want to sit with social distancing and then talk to me about some of this stuff, I want to be available to y'all to ask questions. So I may go grab a quick meal between the 1:30 lab. I have a 1:30 and a 11. And I suspect we'll be out at least 30 minutes early. We're not going to go 2 hours because this Corona stuff. I don't want to be around us that much. We're going to kind of cut some corners and try to. This is an experiment, really, this summer. Well, thank you, William, for coming on down. That made it easier for you. I appreciate that, man. Appreciate you staying in this class. Yeah, that's great. You can even come over here and sit in over here if you want to.
Yes, I didn't know if it was open or not, but yes, sir.
Yeah, we got great Wi-Fi over here. Yeah.
Yes, sir.
You're welcome. You can set up in one of the study areas, because the building's open, you know, and you have a right to, you can be here or you can be over here, and we got Coke machines and stuff. I don't know if they got anything in them because it's been a while, but you can watch the class from up there and one of these break areas over here if you want to.
Yes,
Or the
sir.
library. I love the library ladies. One of my best friends is Miss Wright over there. Melissa, great lady.
Thank you.
Yeah, no problem. Anybody else? Heather, any question? Y'all good? Megan, Zach, y'all good?
Yeah, I was just gonna ask you about I know this is kind of late, but I thought that if I was trying to wonder if this was gonna fulfill my biology requirement. You know how I have to take 2 biologies, and I've already done that, first and second sequence, and then I have to take an extra. I was just making sure. I'm almost positive it's gonna fulfill.
What you majored in?
My major right now is actually liberal arts, but it'll be computer science.
Yeah, this will count as a science elective. It won't count if you're trying to be if you're majoring in biology. But this is the pre-med, pre-nursing classes, and I have a lot of students who've done this and end up teaching high school with this one. This accounts toward high school teaching. Yes, this is a science elective for sure. It's a hard one. Cool. You might could have picked an easier one.
No, I was just this is fine with me. I can.
You want to go into nursing school, my friend. I mean, you should think about it. I mean, on this, if you do good in this, I mean, you can make a fortune in that.
Yeah. All righty. I appreciate it.
It'll count as a big time count.
Okay.
If I were hiring you, I'd look, man, this is like way harder than principles biology, but still, it's a really cool class. I think you'll enjoy it.
Yeah, I've already taken principles 1 and 2 and both.
Okay. Yeah, this would be a good week. You could have took something else a little easier, but I don't know if you'll find anything that's got you. If you end up doing something allied health, like you want to be a occupational therapy or something, then this is one you'd have to have.
Yeah. All right. Well, I appreciate it.
No, thank you. Anybody else? Anybody got any questions? Faith, anybody? Megan, everybody good?
I have a question.
Yeah, go ahead, Heather.
So you said like that 80% of the test would be like today's lesson and then 20% yesterday?
Like yeah, real close to that.
Okay. So just like, would it just be a lot of terms for the first lesson?
If I have a diagram, a picture, I don't have any pictures on this test. I will tell you. You know, because I mean, there's so many pictures. You go, I really have to tell you the pictures that are coming, right? Or it's not fair.
Okay, yeah.
I mean, I had a guy call me one time that we'd be doing muscles and 50 pictures. And he would just pick one random. I mean, my gosh, that was crazy. So I will tell you pictures, and you should not see a short answer question we ain't talking about in class.
Okay.
If you do, then you fell asleep or you weren't listening. But some of the terms I may not cover all the terms, and there'll be a couple multiple choice from the chapter. You know what I'm saying, from the reading. But not more than, I would say I've never put more than 10% of the test would be something I didn't cover, which is really a pretty good number for college teachers.
Okay, thank you.
I will tell you this. I had a guy that taught me that I taught for him. I was his TA. He taught this class. He lectured out of one book, and he told the students to buy another book, and he made the test out of a third book. Okay, so I'm telling you, if you find something on my test that I didn't say in class, or I can't show you the book, then I'll probably give you the point. Okay? Because sometimes I'll do something that's not in, like my thing about the water stuff may not be in my reference to the water may not be in the book, but it's in there. It just may not be word for word. Yeah, I think you'll be fine, Heather. I think you're one of the ones that's going to do well. Okay? You seem to be on top of your game. I appreciate that. Okay? Anybody else? Megan, the question? You good?
I actually have a question.
Yeah, go ahead, man. Is that Logan?
I live a little over an hour away also, and I'm in the 11 o'clock lab. Is there any way I could get moved to the 131?
I really think we should do that. I'll do that. Let me find you, Logan.
Okay.
I really think that's the right idea. I mean, I really think y'all should do that, okay? And I know some of y'all have talked to me about it, and we probably got somebody out. I know I got one girl, Heather. Didn't you want to move to the early one? One time?
One time I did say I wanted to, and that could be fine.
Ain't that funny? I remember that. You emailed me random or something. But yeah, I mean, you want to move down to one of them maybe next time, not today. But if we help somebody that's driving a long way, we might do that and get you out of here earlier.
Okay.
You know, because I think I got 2 wanting to move. And is that okay, Heather? I may move you to 11. Not today. But
okay. I mean, I could probably make it to 11 because I mean, I'm only like a 35-minute drive.
So why don't you come on to I'll move you to my 11 o'clock. And we'll move you to put Logan into one of the afternoons, so he's got a longer drive. Where you live, Heather?
I'm like 35 minutes.
Once you do that, when we do that, that's what you wanted anyway, and I'll just flip it. I meant to do it. I actually remembered that. Believe that or not, I remember your name.
Yeah.
Get you to add. So why don't you do that, and that'll make a spot for one of them in case it's tight.
Okay, so
Come on up
11.
to 11. Come on, 11.
Do you today?
Yeah, I can do that today. Do it right now.
Okay.
So I should come at 1:30 today?
You good? Yeah. Slow down. Yeah. Go back and get something to eat. Just come on. Yeah. Slow
Okay,
down.
is that gonna put me in your class because I was in Mr. Carrera's 11?
I don't know. I may put you in. I mean, I don't know. I'll just got to do what's open. But I think I can get you in 11 o'clock. I think we both got seats. You want me or him? What do you want?
For 1:30?
Yes, sir.
I'd rather have you, so it's the same for lecture and.
I'll do. Hey, if I got a seat, I'll put you in. Okay.
Okay.
That deal. I'll do it because I want to try to please y'all. Okay. So I got Rosalind and. Okay, Logan. I know I wrote it here. Hold on. I'm losing my mind. Logan. Okay, Logan wants to move to 1:30. Okay. Okay, let me do that real quick. Logan to 1:30, and then Rosalind and Heather. Morgan.
So I was in Mr. Carrero's for the 1:30 class. Would that mean that I would be moved to yours for the 11?
Yeah, I definitely can put you in. I think so. Let's see. We'll see. Okay.
Okay.
Good to have you in mind. I'll see if I got a seat. Okay. Well, we had a
So
bunch
today,
of drop, so as long as we reshuffle, it's fine. But I really want to help those that are driving a long way. Would you rather have me or him, or does it matter? He's great.
it doesn't matter to me. I mean,
put you in
do I
mind
need
if
to
I
go
have a
there today at 11?
Yeah.
Okay.
Yeah, come on up. They're right side by side, 207, 209. Okay.
Okay.
I'll do it for you. Anybody else? Question?
Thank you.
All right. Megan, see you later. I'm gonna cut this thing off. Thank y'all.